Hello, hello. Test, test, test. Hello, hello. Around. Test, test, test. Almost working. Hello, hello. Around. Test, test, test. Almost working. Camera. Around. Test, test, test. Almost working. Okay. No problem. Okay. Give me a hot sec. 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 Okay. Give me a hot sec.
Scribe is how four. Scribe is how four. Scribe is how four.
Hello, hello.
Scribe is how four.
Hello, hello.
Scribe is how four.
Almost here.
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 Scribe is how four.
Interesting. Interesting. Oh, hey. Morning. Oh, hey. Sorry. Morning. I broke things. That's why we had to switch locations. I broke things. Super welcome. That's why we had to switch locations. I broke things. Super welcome. Just be a second. That's why we had to switch as I very quickly try to fix all the things. Very quickly try to fix all the things. Very quickly try to fix all the things. Very quickly try to fix. Okay, cool. Well, I do know that I have audio. Looks like I have video. Um, ba, 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 ba. We still don't have cameras and we don't have chat. So we're going to figure that out. Forgot to mention this, all the things. In a minute. Yeah, just letting people know as they arrive. Oh, we're at 4. That's so nice. Thanks, everyone. Just going to be a sec. Bum, 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 bum. Right, we're going to see if we can get this going. Okay. Last thing, we're just going to update folks on x.com that the address has changed. Cool. Done and done. How's everyone's week so far? So I wonder if I could just get a pop-out chat. Can I do that? Chat. Oh, okay. Undone. Done enough. That's all we need. Okay, let's get your camera going here. And we're set. Super set, in fact. Yeah, thanks for your patience, by the way. Just a new platform. We switched from Discord recently. We being me. So never stream. Totally a little baby. And completely changing everything last minute. So you're superheroes for hanging out with me while I mess everything up. Good news too. This is all recorded, so you're gonna get to see every single thing I'm doing wrong in slow motion 4K HD. 4K HD? That doesn't make sense. Okay. There we go. La 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 la. Now we're done. And we're ready. Can't just be my stream that starts like this. I'm sure other people stumble immediately as well. Or if it is just me, then let me know because that's hilarious. Hello, camera. Are you here? Oh, not what I want. All right, so the last thing we're trying to do here, just before we confirm that everything's good to go, is we're just trying to get the last camera going. So the last camera is what I call pretty cam. Pretty cam just lets you see my face and everything else that's going on. This is what I get for very last minute changing one critical setting. I tried to log out of my test account, this one, you're on my test account right now, and into the real account, which is researchanddesire.com. So, or Research and Desire, Twitch. So that's what I'm rushing to go correct inside of OBS right now, off screen. It's, again, amazing content. I'm sure. I'm sure. But thank you so much, you little heroes out there. Okay, phone needs a restart. Phone is camera one, just so you know. That moment when you open your phone and you have to realize that you're very much disappointing Duolingo. You know what I could do? I can go camera 5. Camera 5 or 6. Hi. Hey, I'm here. I exist. Got my little outfit on. Got my little mess in the background. Which you'll pretend you don't see. Okay, folks. We're so close. So welcome to my super sloppy messy chat, super sloppy messy stream, where everything was so ready last night, and then I don't know what happened. I guess I just logged out of the primary account, and so now we're on my test account, Research and Desire AJ. We'll hang out here all day. I'll keep the stream here, of course, but lesson learned: don't try to change a major login 5 minutes before you start a stream. Not a good idea. All right, let's check. Oh, somehow this is getting listed as a rerun as well. That's insane. But no, promise it's not. I'm right here. It's just gonna be a thing I don't fix. It's like a meme I saw the other day. It's just a GitHub screenshot of a developer who saw an issue, and then somebody follows up like a year later saying, "Hey, is this fixed?" And the developer said, "No, I just decided I don't care." That's my life right now. Hopefully not on awesome, but just on these Twitch bugs. Ah, six lovely people. Thank you so much for joining. That's so kind. We're gonna be kicking off here pretty soon. So what I'll start with is the same thing as usual. We'll get into freeform. I'll tell you what's up, what we've been doing, what we will be doing, and we'll get into some live coding. Right now, what can I tell you? You know what? I have freeform going. I'll get you on camera one. Camera one's the pretty cam, and then I can go sit down. Show. 2 seconds. Let's attempt pretty cam. Hello. Hello, pretty cam. Hello. We also are using tape today. Everything is always perfect. Always the way it needs to be. That, or you have to live life as a pessimist. And I refuse. Okay, so you can't see it because we're using Prettycam, so let me switch over. Prettycam normally has a tripod, but tripod broke. So Prettycam gets face tape. Face tape attached to barrel. Okay, let's test at the angle of Prettycam. It's okay. It's okay for a little tape on a barrel. Oh my God. 150% that'll do. And I guarantee Prettycam is falling today. We're gonna see that. All right, let me check a little. Okay. All right, you can see me if I'm down here. Love it. This will do perfect. All right, 2 seconds. Last thing we have to do is just go get the awesome. And she's downstairs. Be right back. All right. See you, Prettycam. Where are you? Okay. We're going. Control 1. going. Some nice framing for sweet little awesome. And one of these, one of these, one of those. So please go straight up. Okay, baby. I think it goes without saying, but this little finger attachment that I have is not body safe. Whenever I'm taking my awesome out on the road, show it off to people. Sometimes you never know. You never know what people are cozy with, comfortable with. So I like to keep it a little PG. Okay, not bad. We're gonna lower pretty cam just a bit. Where's my headlamp? Pretty cam. And hey, pretty people. Okay. Swear to God, we're all professionals here. I'm just kidding. I have no idea what the fuck I'm doing. Like 80% of context, no idea. So, c'est la vie. We just power through and attempt to piss off the fewest number of people, but you know, confidently go forward. Okay? Pretty light. Pretty cam, pretty light. We got half the things. Crisis averted. Life is good. Pretty lights down there. And oh yeah, baby. Somebody asked me what's up with this get up recently. And oh, I just thought I felt like I needed a uniform. She's a good friend of mine. She was like, "What are you going for? You going for like a gardener, it's like a gardener aesthetic?" And I said, "No, I think it's more like sex barista. Like I'm cooking up something fresh in the shop for you." So that's my vibe today. We're going sex barista. Gonna charge you for I don't know what, like a $12 coffee, I guess is the implication. All right, pretty cam. You're almost good. Yeah, not bad. Get my little mushroom lamp in here. Printed by a good friend of mine, designer in the city. My city, at least. For those who don't know, I live in Bangkok. I live in Thailand. Canadian still, of course, but just living life, you know. Cute. Bicep plant, which does not have a name. It's over there, and awesome is here. Everything can be seen. Everyone's happy. Ugly chairs out. I think we're as set as can be. Yeah, last thing's just electricity. And then, good morning. Oh, hello, I see you. Ahoy! Oh my God, the AJ. That's me. Oh, is that the Lucy? Capital T, capital L. Lucy, my dear, we fucked everything up this morning. But it wasn't my fault. It was whoever owns Twitch, CEO of Twitch's fault. It is indeed the. All right. Pretty Cam has tape. Awesome is semi-visible, at least efficiently. Is it Bezos? Did he take this one? What a man. What a man. Okay. Let's get started. Paper. Paper. Yeah. Yeah. Fucking rip. Stop buying stuff, guy. It's like you're the richest man in the world. Oh, okay, folks. Thank you so much. That was a 27-minute delay. So every single one of you who's hanging out here in chat is an absolutely gorgeous goddess. Uh, uh, and that word with whatever gender you prefer. Seriously appreciate all your patience. So today we're picking up where we left off. This is part 3 of a little series where I'm developing a feature live with you all. start to finish. Basically every single line of code except for terrible things that break. Those things I'm going to try to fix off screen, and any amount of polish is going to be off screen as well. For the most part, we're just going to have you all focus on working out an MVP with me. I'm going to catch you up. Every day is going to start with a bit of a recap. So we're cracking open freeform here, and we're going to recap you on what we're doing, why we're doing it, and what's going to be cool about it. OBS is telling me that freeform is not sharing. No worries, no worries. Okay, first things first, we've decided that we hate freeform. So everyone be aware of all the whiteboard tools. It is not one of the good ones. That is okay. We power on. All right, freeform, awesome pattern drawing. That's not freeform, thank you. Here we go. Fun. And we hit okay, perfect. Okay, so last week, we are on session 3, so session 1, we posed to the chat, we were in Discord before, a couple of different ideas for what we're going to do for these live sessions. The ideas that came up were, A, we could get inspired to work with the Awesome Possum concept and build out a parallel app that works with that, but we agreed that that already exists and it works pretty damn well, so it's not so exciting. If you haven't used the Awesome Possum app, quick name drop, we recommend it. It's fun. It's a lot of fun. The second idea that we brought up in that chat was the drawable pattern system. So in this pattern system, the quick brief is you squiggle your finger, you do something, and all of a sudden you have a pattern on your device. We did a whole bunch of back and forth on what the MVP for this would look like, what's required. The key takeaways would be that it's going to be a drawing tool in the dashboard, which we were able to mock up, and I'll show you that in a sec. It does work locally, of course, as an MVP, where you can draw a cubic spline or a spline. It doesn't have to be, I have to confirm if it has to be cubic, but a spline, given that it meets a few mathematical conditions. Those conditions, pretty simple. It's a C1 continuous pure function. All that means is first derivative is continuous. There's no crazy impossible accelerations. And the acceleration limits and speed limits match what's on the machine. But also, the function doesn't loop back on itself. You don't have any of those things that you can do in Illustrator when you're messing with the handles of a spline. That's going to be limited quite a bit, just to make sure that things are, physically possible. I think that's a reasonable request. What do I got here? First time chat. Okay. I don't know what this is, so I'm gonna ban you. Sorry, my friend. That seems very bannable. Uh-huh. Yeah, dude. How do I do this? That's the sad thing. No one run to chat and click on this link that this dude just posted. Um, but I'm so unk at stream at Twitch that I am just right clicking over and over and doing inspect element. This cannot be the solution. All right, go back to chat. Yeah. Where's this fella? Hey, sir. We are going to definitely report ban. Thank you. But weirdly, I still appreciate that we got a bannable person so early on. That's hot. Love it. All right, so thing one. We got this little dashboard going on. Just checking that is okay, cool. This dashboard is working. We'll take a look at that. It required some database changes. Yes, one of the freeform things for those who were not here in the previous chats, it does not have icons. There's no icons here. The database is a bowling ball, and the Bluetooth utility that communicates between dashboard and the awesome, that's a Bluebird. These are the closest things that Tim Cook decided to put in here. Amazing, by the way. Yes, just zooming through to keep everyone up. So we have this unicorn. Unicorn means it's a feature that we think we're not going to do during MVP. That's fine. And we broke up the work on dashboard into like blocks. These little blocks work. We're using hats at the moment to determine the state of the work. And it's all random, just so you know. Nothing's going to be too logical, which is why we're going through the legend really quick. Top Hat is in progress, looks good. A little cold. Toque is it's MVP ready, but definitely not going outside right now. It's a little too cold, a little too frosty. So the current state of things, as we're going to see them, are yes, we have a dashboard pattern drawing tool. I'll introduce you. She's cute. We have a database structure for saving these splines. I'm going to cut the word cubic because I don't know if that's actually appropriate. It certainly is a spline though. We do not have the BLE sender on the dashboard page, but we're not going to work on that today. I'll talk about why. We have a feature, so a unicorn feature that we are actually able to complete for MVP, which is that list of all available patterns that we'll go through as well eventually. We started a validation system. So I mentioned the C1 continuous pure function thing. That validation system must be in place on the dashboard. This is not in place yet, but it has been started. It's just not sufficient even for MVP. Okay, cool. Everything else has not been started here. So we've moved on to a different stream of block of work, a different set of blocks, where this second set of blocks is outside of the dashboard. Now we're going to be on the device. How do we take a pattern that you drew, a little squiggle, and how do we put it on the awesome? That's what these blocks are, and that's what we kicked off last time, which was last week. So a little context before we jump in. This is the flow. This is the decided flow. We draw something, it's in the database. On the dashboard Bluetooth or BlueJ here is going to send a UTF-8 encoded, not binary, payload of about this structure, ID, name, description, version, and spline. This is going to be received on the awesome and parsed into Arduino JSON. Love it. And then it's going to be sent to a motion planner. The motion planner is a pinata. We don't know why. Okay. Crown implies awesome whenever we have duplicated symbols, but we're not going to stick to that trend forever. We just like hats. Okay. What else do you need to know? Yeah, okay. So the last thing you really need to know is that even though this is the target solution, to make sure we're really honed in on delivering MVP style, we're not even going to do this Bluetooth connection yet. The very first thing we're going to do is we're going to work on reading a pattern from memory. Let's work through these blocks of work, make sure that I have it up to date in my brain and you have it up to date in your brain. So the blocks are first, these are not in order. Yeah, things we have to do today. So we have to modify stroke engine to allow you to play custom patterns. Right now we have the 7 or so patterns that come default. We are not going to have a new mode. We're just going to extend stroke engine to permit these. We're going to add a characteristic, so add some Bluetooth information for receiving patterns as you're sending or creating them. Love it. Oops, I just remembered I have to update one additional place with this new link. Excuse me for a second. We have a friend of mine here who's playing support. And they're still in the previous link, which I could not log into today. Okay, done. Okay, back. Perfect. Okay, unicorn thing was modifying the characteristic for reading patterns. This is mostly for radar support. So yeah, unicorn because, hey, that's not MVP. And then motion planning. Ooh, yeah, lovely conversation in the awesome Kinky Makers Discord channel with Frey about the motion planning system. And we're totally in alignment on what that has to look like. It is definitely going to be something that lives on the awesome. What the real thing, if we want to break it down into what we mean when we say motion planning, I give you a spline, a curve, you still have to move a motor. And the question is how? How do you move that motor? What commands do you send to the stepper? At what time and what frequency? Given that it's going to be some kind of trapezoidal solution to move to that point and you don't want to spam the motor and you want to take into account the speed, stroke, depth, etc. That's the motion planning system we have to build. It's very interesting. It seems like the first thing we should start with, but it actually isn't. So a couple other unicorns here that we want to have, but will not have in our MVP. We want to be able to, excuse me, save patterns on the device that's over here so that we can do it, use this pattern in the woods. The vision here is you draw a spline on the dashboard, you download it to your device, you go to the woods, you have a great time, everyone's happy, and then that is just on your device forever. You can update it, you can do a version check against the other, that specific spline. So if that spline updates because its creator made a modification, you can download that modification. It's just kind of continuous improvement, right? That's this unicorn. Okay, I already mentioned the version check. So you could update and a bit of management. So you could delete patterns that are on your device and they're not just sitting there collecting dust. All those things are not happening today. But the one part of that system that we find to be so critical and must be the first thing we start on before motion planning is actually just loading patterns from memory. So we have to store a pattern in memory. I'll show you where we're doing this. So inside of this, the repo here, I'm going to also, what is this? Oh, just settings. I don't know if you can tell, but I'm doing everything at 1/4 resolution of a MacBook Pro. Let me see if I can show you my screen right now. It's kind of chaos, actually. It's a little, for anyone who's developed anything ever or does anything on a computer, this is insane. This is insane. This is how I live right now on stream. Tiny, tiny, tiny windows and my stupid little glasses leaning in to try to see everything. But I tell you what, I refuse to get a desktop. This is a spiritual ground I will die on. It is so much more convenient to be your little sex barista with a laptop working in the middle of a coffee shop. It's my dream. So, jumping back to real life, here in the awesome repo, we have a whole bunch of stuff. Let's make sure we're on the right branch. We are on fix BLE rehome, which I'll tell you what, that is not right. So let's go W2 here, get checkout. Oh, what did I name the branch? Probably AJ patterns. Ah, okay. We'll have to list. Aha. Ba, ba, ba. Where is it? Patterns, patterns. AJ, awesome patterns. See, I would have embarrassed myself. Get checkout. Who cares? Get stash. Okay. I know. Okay, people use stash. People definitely use stash. I know this is the truth. I've used stash correctly before, stash pop, but it just, if I'm being honest, I just use it as a garbage bin. It's a quick way to just throw out whatever the hell I was working on and move faster. Get checkout. Okay, awesome. No. Yeah, okay. Get checkout force. We'll pay the consequences later. Okay, done. All right, perf. There we go. So as I was saying, we want to load patterns from memory. So inside of the repo, we have now this data directory, which has patterns. So these patterns are as follows. Let me close this guy just so you can see a little bit. Close this bad boy. We have a couple ideas here. We're roughing out the structure. We're not going to worry about it too much. But the first idea is that you have a registry. And this registry is, again, literally this JSON file uploaded as a JSON file into, hopefully, little file system, little FS on the awesome. That's the dream. This then will reference every single pattern by ID and carry its details so that you can go check. So you can load up the registry and say like, oh, okay, I have these 5 patterns downloaded and I choose this one by ID, ABC000. What will happen next is the second you click on it, it will open up this actual pattern file. The only difference here is that it will contain whatever other metadata we want to carry. Critically, the cubic spline, which we're going to rename to just spline, because mathematically, I don't know if I stand behind it being pretty, like, a cubic one specifically. Anyway, we're gonna get into that later. If there's math people in the chat, just go for it and tell me what the right name is. I am a math people, but I'm not in the mood to Google and run a chaos stream. I'm gonna do one of those two things, and that's it. But I invite you to help. Okay, so registry loads up this file. This file then is going to be the pattern that we then pass into the motion planner. Done, done, done. Okay, what do we need to start here? I think I need a water. And then we got to do just a little bit of understanding where we left this piece of work. So we're going to do a quick AJ gets a water. All right, BRB. AJ's mouth is so dry. Boy needs water. Okay, back in 2 seconds. I've acquired floor pillows. I have a roommate, and whenever my roommate walks by, because I don't have a desk, decidedly, he's like, AJ, I just every time I see you, you just look uncomfortable. And I'll tell you what, he's not wrong. He's not wrong. Objectively, there's a reason these things exist. By these things, I mean desks. I just don't like. Just on the mood. Yeah, I could buy one. Just don't want it. Too bulky. Do you ever notice that there's always one fewer USB cable than you need? All right, let's see. I'm getting a lot of butt shot of me. Sorry. Okay. There definitely is one too few, but we'll figure it out. Okay. Oh. I've been visiting these artists in the city. Started a bit of an artist collective, very like Soho in the 70s vibe. And to support, I frequently leave little things, you know? I guarantee one of the cute little things I left them was a USB cable, USB-C to C cable. Huh. Okay. Crack, crack. Draw strap. My system audio and mic very off. The mic should be much louder. Oh, thank you. There's notifications coming through. Notification noises. Well, first off, appreciate the input. see if we can fix this together. System audio and mic volume are very off. Let me do a terrible thing and quickly unmute this. Infinite echo coming in. One sec. Test, test. Infinite echo coming in. One sec. Test, test. Test, test. Infinite echo. Okay. I don't hear notification sounds. So we're going to turn on Do Not Disturb. And then hopefully, you know what it is? Cursor's probably insanely loud because it makes notifications like mad. Let's check this. The truth is, I was hoping that cursor... All right, cursor's muted. Let's check Chrome. Chrome is muted. Let's do a quick check. I'm just gonna do a test in Chrome. Let's go like test audio. Sure.
จบปี44
Pure audio poison. Hey, camera one frozen. Why camera one frozen? That's odd. Huh. I do see that it's frozen. Test. Oh, back. All right, check in here. We're gonna check to see if audio is coming through on Chrome. I'll tell you what, I don't see it. So I think what's up is much more annoying, much more annoying. I don't know how to pronounce your name, but I'm gonna try Fridjtov. Let me give me a moment there. Fridjtov. Well, Frid, if that's okay. I think what's happening is, in fact, because I'm using my MacBook microphone, we're actually picking up any kind of cursor sounds or notification sounds on that microphone. So we're just going to mute that completely, and then we're good to go. Is this working yet? No. So strange. Yeah, I'm seeing Twitch frozen. Do you all see Twitch frozen? No, good to go. Seems to be working. Quick unmute. Yeah, okay. Audio is not coming through any of the applications as far as I can tell. Audio is not coming through any of the applications as far as I can tell. Audio is not. Oof. God, that's terrible to listen to. All right. Just in case, just to make sure we're not poisoning everyone, we're going to mute any application that might have a risk of sending noise in. Ba-bum, ba-dum. I wonder if PrettyCam uses a different microphone. We're going to make sure. Nope, good to go. All right, well, let me know if it's still terrible, and I'll help you out as much as possible. Okay, so we're back at the registry. We're gonna get our big white pants on, figure out what we're up to, get a little coding done. I'm here until 10-ish, so we got about 3 hours. Let's set some goals. So we'd started here. I want to load patterns from memory. How far did we get last week? Let me try to... I want to pull PrettyCam closer so I can get comfortable. I wonder if I lose it. Just make sure you still have me. You kind of have me. Good. 3, 2, 1. Goodbye, PrettyCam. Hopefully you're still here. PrettyCam failed. Okay. PrettyCam has decided she needs to be plugged in. That's okay. So here we are. I want to learn patterns from memory. Let's go take a look at our code, figure out where we're reading the registry, and just understand where we're at. So registry.json. I recall last time we were stuck just slightly doing little file system prep, trying to make sure that we were actually reading from little file system and getting out of spiffs. It looks like yes, to a degree, we were making progress there. Little fs registry.json. Man, a little messy. Not a big fan, but let's give it a go. To be clear, the thing that I think is a little bit messy is that it's using the expressive commands to read little file system, which are totally fine. Totally fine. If you're in this ecosystem enough, you know that expressive and Arduino, they don't actually play well together perfectly. In the context of the OSSM, as well as all research and desire products, generally what we do is we build the expressive framework and install Arduino as a component. This is the standard. If you do anything in Platform IO and you're adding Arduino onto an ESP32, that's exactly what you're doing. Whether or not you build expressive yourself or let them build it for you, depends on your platform io.ini file here. I'm not sure the technical level of everyone in this chat, but I assume it's moderate, or at the very least you're curious. So I will occasionally just pause and tell you some stuff. So right here, inside of platform io.ini on this line, if you set framework to Arduino, which many projects do, then you're installing the pre-compiled expressive framework and then adding in Arduino as a component. Great. The thing you fail, or don't fail, but like don't get access to, is any of the compilation level expressive config variables. So that is the entire SDK config, which we do want access to inside of the OSSM repo so that we can maintain Bluetooth, MQTT, and HTTP requests concurrently. That is a tall order. That is where we need a bit of custom control. The downside here in our specific context right now is that it is more difficult to get little file system working here. You know what I just noticed? There's no chip on this. Where's my chip? Because what I want to do now is I want to flash this onto an awesome chip and just see if we got past those issues. I'm gonna have to find the real one, which I'm sure is just downstairs. But off camera, I got a whole bunch of these dang things. So we're just gonna flash this bad boy, just see what's up. Huh. Yeah, I wonder if that's a. So when I was at the little artist hangout, I brought the awesome, of course, because I'm working on it, and they loved it. I had it synchronizing to music, so using the MacBook Pro microphone, it would just listen to any incoming signals, do a little frequency analysis, and then change settings based on the frequencies and volumes that it was hearing. It was a fun project. And now I'm concerned that my chip is there, because that chip is going to be required for actually controlling the motor. But for testing little file systems, we're okay. We're right here. We got a version 2.1 board in my hands. Let's go. And brass wraps, baby. Whoop, 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 whoop. Oh, by the way, we're going to be a little bit faster today. I didn't buy any new tech, but by switching to Twitch, I've offloaded all the effort of compiling or encoding the video on my computer, which means life should be better. If you were here last time, you know that we actually ended because my computer genuinely could not compile. My half decent MacBook could not compile anything. Okay, let's go. PIO run on awesome repo, CD software. Right. So the check that we're doing now is simply this little file system work. Do we have to go crack into some deep stuff, maybe just vibe code a thing to see if it comes through? The hope is that little file system did work in our last setup, and that we're now at the point where we're just simply reading the files. Ooh, you know what I have to do? This is a new chip, so I have to really quickly upload the data directory. So inside of platform IO, the extension, or you can do it using the terminal. I'll show you in the extension and I will do it in the terminal so you see both ways. We have to do an upload file system. So right here in the terminal, I like doing PIO. This would be run target upload fs, I think from memory. do not know how to make file target. You don't know how to make file target? Okay. Hoping for the best. Wish us luck. By the way, I got chat open, just like classic cool kid streamer boy. So if you get bored, send me memes. All right, files uploaded. Not sure why it failed via CLI. Yeah, hit me up if I just messed that up somehow. Maybe I just typed up loud or something. Who knows? Moving forward, don't think about it too much. PIO run. Let's go, baby. So now we have the data directory uploaded. So inside of our, let's go make sure that we're communicating, because that's the key to a good relationship. Inside of minspiffs here, you can see our partition file. Disregard the fact that this looks like Excel. That's my bad. Installed an extension, haven't removed it. We have all these different allotments of memory space, which tell us what goes where. So we always have two app sections. These are for over-the-air updates, which we still want to support on this device. And then spiffs. It is called spiffs, but we are in fact using little fs. This must be named spiffs though. This tells you where we're storing those JSON files. So when I do upload fs, every file that's inside of this directory gets pushed into that spiffs memory space. Okay, let's take a look. I saw a little red. I did see red. No. Okay, let's go. What kind of red did we see? Okay, very likely this is going to be the kind of thing that we are going to pitch over to the AI. I'll tell you what I see, tell you what kind of error I expect this is. In the include for ESP little fs, we're seeing something that looks to me like an import loop between these three files, these four files. I don't want to deal with that headache. So I'm going to get the AI to fix it. Again, part of the thing here is I'm gonna assume that you're the listener or a technical person who wants to just learn a little bit. So the piece of information, the tip I'm gonna give you is never ask your AI what to do, tell it what to do. Have a solution in advance and then make sure that it's following your orders. You're the top in this moment. So here we go. I'm gonna say to this bot, because I think I know what's up. Hey, this looks like a memory leak to me. A memory leak to me. Like a memory leak to me. Not sorry, not memory leak. Memory loop. Ah, brain. An import loop between these files. Please confirm that's the case. Not the case. And if it is, then fix it. While that runs in the background, let's go talk about a registry reading device. So, or the piece of code that's going to read the registry. Make sure that I understand what the plan is here. So we got this thing, it's like concept of reading the registry. And we're going to talk about this scope of work. Yeah, sure, reading, but also then adding that, pushing these registry files into Stroke Engine. So first things first, pseudocoding here. Dun, 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 dun. All right, so we need to open a file called registry.json on boot, save the names and IDs, just the whole info, save the Arduino JSON object for this, so it's accessible, and is a global singleton. Singleton is not the most accurate term in this context, but global is more accurate. I like calling it singletons though, so I'm going to keep going with that. Global singleton of this memory object, of this object called, who knows, registry thing. Ba-ba-bum. Okay. This is so that we don't have multiple memory instances and have very, very low risk of doing multiple memory instances. We've done this in the past where we've accidentally not made something that into a global singleton, and the consequence of that is that you are always passing forward the reference to the instantiated object to anything else that needs it. It is just annoying. It's pretty annoying. That's about it. So by adding or using as many global singletons as possible, we just make our life a little bit easier. At what cost? Good question. I'd say the biggest cost is, oh yeah, I forgot to mute cursor. So you're getting crazy notification sounds over here. Cursor. Get out of here, cursor. Yeah, okay. I hear you, I hear you. You're driving everyone crazy though. General, settings, notifications, no sound. Mini bar icon, that's okay. Notifications, okay. Good to go. All right. So the downside of doing global singletons for a lot of things would be class instantiation. So if you needed to have a single ESP32 that had two instances of awesome, the class, with two instances of the motor driver fast excel stepper, you'd be boned because I have one global singleton for fast excel stepper. That is not our case anywhere in production, as far as I'm aware. It's a very exciting concept, but just isn't the case. If we get to a multi-motor setup, then it might be more critical. For now, no. I do want you to dream, though, of a multi-motor setup awesome, like a full robotic arm. That'd be sick, right? Love that shit. Okay. Yes, so on load. Come on, cursor. You're driving everyone crazy. All right, give me a hot sec. Mute cursor. Yes, Command Shift P, or we're looking for list signal sounds. 31 selected. My gosh. Well, see ya. Here's hoping. Frid, if it's okay to call you Frid, let me know. Hopefully this sounds a little bit better, a little less chaotic, but yeah, it was just cursor going nuts. Okay, our machine is recompiling. We'll let it go. Easy, easy, easy. So we load this up. Yes, we have a single instance of this, and then we need to pass this into stroke engine. So let's make sure we understand this flow. Let's talk about that. So stroke engine dynamically loads its patterns when you click on them, but it preloads the pattern list. Yeah, so it preloads the pattern list on boot, actually on compile, because it's just a string array. So if we wanted to have our new items inside of this array, one argument might be that we just extend the existing array when we read the registry. I don't know how I feel about that. It would require a reboot every single time you changed or like downloaded a new file. Yeah, we're not too sure about that yet. So what we're going to say is we're going to pass this registry into Stroke Engine for pattern names and selection. Okay, no, we got to talk about it. We got to figure it out. So we're going to have still the classic patterns will be there. And in addition to the classic patterns, we must have now also the registry patterns. And when I say there, I mean literally when you enter Stroke Engine on the display, you go to Patterns, which I believe is a double click on the right button. We need to now list our additional patterns. So in our case, this is going to be called test pattern and test pattern, well, also test pattern, but we'll call it test pattern 1 and test pattern 0 with the descriptions. Okay. Da-da-da. What is the best approach here? So let's go through the code, just to kind of understand. For anyone joining, because I see some people popping in and out. All right, just didn't want you to, but we'll say that. Yeah, don't worry about it. Frid, go ahead. Interrupt the stream constantly. Truthfully, I'll tell you what. This is not a lecture. This is AJ hanging out with Frid, as far as I'm concerned. This is like you and me time. So just say anything, anytime, not an interruption. Yeah, please. For real, like if you have an out of body experience and just consider what I'm up to right now. I woke up at 5 a.m. to sit alone in my room and talk to, no joke, my phone taped to my laundry basket. If you don't say something in chat, I'm actually insane. I'm a crazy person. I have a tuna fish, I'm not joking, over there, like a fake one, so that I feel like it's two people in this room. That's not exactly true, but I'm gonna lie to you because it's a fun story. Please interrupt the stream. If I wanted to be alone, I just turn the camera off. Okay. Bra strap. Someone's got to teach me how to wear an apron. Okay, here we go. So we know that we want to extend the list of stroke engine patterns with these items from registry. When we're reading registry, what are we doing? So we open the file, read the buffer, deserialize JSON. This is the Arduino JSON file. Check for an error. But where? Just want to make sure we put it into buffer. Let's just make sure I'm not crazy. Deserialized JSON should be an Arduino JSON thing, which means memory.h is importing that. Let's go confirm. Tell you what, my computer's less crazy. It is in fact still crazy, as in pretty slow. But Arduino JSON is coming in. Good stuff. OFS, we have a compiler issue, which I'm going to briefly fix by making this full screen. This might make things invisible. Yes, I tell you what, it did not work. Let's validate that you can see everything still. You can, brilliant. So, failure, but that's all right. We load the registry. If it fails, it fails. So here, when we go into Stroke Engine, let's go take a look at that. So inside of state, so awesome. Let's go awesome.h. We should have our state machine. Inside of, perhaps here, machine.h. Good stuff. This is our declarative state machine. Tells us exactly how we're moving through all the different possible finite states of the awesome. You can only ever be in one state. It is so nice. Pulled it from my background as a amateur game developer when I was a little baby boy. If you don't know, I assume you know state machines. If you don't, I hope I've described it brief enough that it kind of makes sense. There's one state. There's actions that transition you through the states. You have to pre-register these actions so that you know to listen for them. Menu.idle, for instance, we listen for button press and we check, is the option on a button press simple penetration? If it is, go to simple penetration. Very declarative, very easy to read, very, very simple. This prevents you from having, you could imagine, 1, 2, 3, like 9, whatever this is, 8 if else conditions. The problem being when you have multiple conditions that stack on each other, becomes an unmaintainable nightmare. So a finite state machine, or a state machine in general, is so friggin' wonderful for cleaning up complex inputs and complex active states. Okay, so that's this one. The specific file or specific state machine that I'm using is called Boost SML. It is, although it is called Boost SML, it is not part of the Boost universe, as far as I can tell. I did some reading on this back when I first implemented it 3-4 years ago, 3-ish years ago. Boost, I don't know. I'm not a huge CPP expert in as far as Boost is concerned, but Boost gets a bad rap, is what I found. Like, people kind of don't like that universe or that ecosystem of things. Boost SML, which is not part of the universe officially, is fucking great. It's so good. Huge fan. Props to them. Okay, so when we enter Stroke Engine from the menu, so first off, I'll walk you through it. Might as well. If we're in menu idle and we get a button press event and the option is Stroke Engine, we go to Stroke Engine. If we're not homed, we start homing and then we return to Stroke Engine. That's here. If we are pre-flight safe, so we pass all our pre-flight checks, then we reset settings. That's a new one. I don't think that's me, but that's okay. We draw the play controls and we start Stroke Engine. Good stuff. This could be done in an on-entry task here, but I can understand why it's not. Okay, so not worrying about that. I do see exactly why it's not. I will share with you just so that I'm not, keeping you in the dark. Essentially, if we did have reset settings, drop play controls, and start Stroke Engine inside of an on-entry task here, where on-entry means the second you enter it, then every single time we go from pattern to idle, we'd be calling those functions, those entry functions, which we don't want to do. So if pre-flight passes, we go forward into idle. So from idle, if you double press, then we go into the pattern selection. In pattern selection, right. So this is one of those places where probably we should actually switch to an on entry just for convenience, because this doesn't read cleanly. So draw pattern controls. I'm going to switch to being an on entry task while I'm here. We're going to make sure that I don't break everything. Impossible to make sure, of course, but believe it is SML on entry. We're going to check our syntax. Do I have another on entry to compare against? Maybe it's one of these. Oh, we'll just go look in any other repo. But simply not that file. Okay, so on entry syntax. Please, sir, please. Ah, right, okay. On entry underscore. This is just dancing around internal syntax. And then your function. Okay, good stuff. Drop play controls. The second we enter the pattern drawing util, we'll be here. Get to draw these. Okay. So drop play controls is not going to be the place where we are going to do this. I'm going to guess that it's going to be relevant in reset settings stroke engine. Let's go take a look at this function, find out where she's defined. I am also gender neutral on my functions, but I'm saying she in this context for truly no reason. Just in case you're curious. This is not relevant, so these are encoder settings, not what we're seeking. So probably in then start stroke engine. Let's go find this. Yeah, okay. Well, I did a refactor and I dislike that it's got that there, but we're going to go forward. So publish state task and start stroke engine task. Okay, we have these two tasks. The two tasks, as we enter stroke engine, what I'm looking for, I'll let you know when I find it, is there's a place. Yeah, dang Lucy. Yeah, please do. Anyone who can't see chat, which would be all of YouTube, Lucy just said that she's going to call the pronoun police. I wonder, yeah, this is maybe a good AI question. What do you think the pronoun police look like? Like, what's the uniform? It's not just a police uniform, right? They got to have something else going on. Okay, so here, pass forward the stroke machine geometry. Good stuff, good stuff. Where are we deinitializing fast Excel stepper? What? Bum, bum. La da da. I see you, Lucy. You funny. Huh. Also, what's going on here? Cursor. Yeah, thank you. Okay. You, Lucy, can definitely share your thoughts on what the pronoun police look like. I think this is the most appropriate place. I will say I'm eventually going to upload it to YouTube. So as long as it's YouTube-ish safe, we have no sponsors, no financial sponsors on YouTube. So go crazy. Not that crazy, but go medium crazy. Hmm. Yeah, if you generate a photo, I will absolutely find a way to share that photo on stream. Okay, just gotta keep OBS open. I have trust issues. Not generally, just with OBS. It has been so good, actually. No joke. Anyone who streams knows OBS is the GOAT. Absolutely wonderful. But I just don't trust it. I just, every single time I see a 500 millisecond lag on Twitch, which is in my top right, I'm like, OBS, you're poorly acting. You're doing something wrong here. But no, it's always chill. Okay, I was looking for, yeah, I was looking for where we're deinitializing the patterns that I could, or fast Excel stepper, or passing fast Excel stepper forward to stroke engine, but that is not something I'm seeing immediately. So it's not critical. Again, the objective that we wanted to answer was when are patterns getting shown, presented to the user, and importantly, yeah, we have a couple things here. So a couple notes I'm just going to pull out. So stroke patterns is going to need to change. Stroke patterns is the array, I believe. Let's go check. Should be defined as the array of patterns that exist for stroke engine. Da-da. Yeah, or an enum in this case, it seems. So this enum will no longer be useful. Right. Is no longer sufficient. Maybe we switch to everyone's favorite unordered map. I don't know. We'll see. But a little harder, or ordered map is more appropriate. But we don't care about the efficiency, so a vector, although well hated, is probably fine. We would do std vector. Std vector is the same as a vector, just wear protection. It's a bad joke. All right, let's see. That definitely will have to change. And when we do draw patterns, let's go find that. Draw pattern menu. Okay, back to our machine. Draw play controls, draw pattern. Draw pattern controls. And by the way, we should do an on exit here. So this is a, yeah, okay. We don't want to do on exit. I don't know, we do. Yeah, right here. Long press, emergency stop, not home. And menu. Okay. No, we won't do it on exit. We have different exit conditions, one being emergency stop and one being double press or press. So selection. So I was hoping to do a bit of simplification on the tree, but I'm not going to do that right now either. So draw pattern controls is the name of the function. Let's go find it. Inside of awesome, inside of software, inside of source. This double nesting thing is insane. I'm gonna clean that up. That is an offline task. Okay. So if we are in the pattern menu, this is our is in correct state function. Then what we're going to do is we're going to read the encoder, divide by 3, where this is a controversial thing I implemented that I'm going to remove. In fact, I will just do it right away, where 3 clicks is 1 transition through the table. I'll tell you why I did that, but it's just not critical right now. So should update display, carry on. So this is where we start to get into problems. So inside of, so we know that the stroke patterns array is no longer sufficient, or enum. Perhaps an unordered map, perhaps an STD vector. We're not sure yet. We also know that the UI strings stroke engine names is not, which is an indexed char array from progmem, is also not sufficient. Okay, so what is the easiest thing to do here? The easiest thing to do is to allow the index. So we have an index that scrolls through these enums, where the max value of the index is the max value of the enum stroke patterns. This we could probably simply replace with number of patterns, like a variable defined at not compile time, but start time at boot time. So new variable. Number of patterns at boot time, which is your length of enum stroke patterns plus plus length of registry. And then when drawing pattern, so when draw play controls or pattern controls is running, we allow the index to run up to the max rate. And we'll assume that if you've exceeded the enum, then you're drawing from registry. Okay, cool. This does nothing at all for pattern control, or motion planning, I should say. So the next big issue here is that inside of here, so probably inside of machine, inside of start stroke engine, which is pre-flight, drop play controls. Play controls here is running in the background the entire time. So of course it's always listening and it never shuts down. So draw play controls, not a machine, but here we're gonna clean this up. Drives me crazy. Drives me crazy. So we have a function whose only purpose is to call a function. That's insane. That's unnecessary. The reason it exists is because I did a refactor and it had to be a lambda function, and a lambda function just has a slightly different syntax than like these ones where, anyway, it's okay. Just drives me insane. Because then that function, its only purpose is to start a task. I've solved this in our other products by having a method called start task. That's it. Anyway, I'm gonna not ramble on this one. No story time. No story time for you. Soup Nazi. So the biggest problem here will be as we enter this. So this is the start. We're in the correct loop. So this is the play loop right here. Fun fact for anyone who's kicking around, there's a flag here called AJ Development Hardware. If you've ever been curious what that is, this flag, AJ Development Hardware, it's literally this. Like this is AJ's on a plane or AJ's on a bus and he can't put out the awesome, but he wants to do development or like critically must do development on the awesome. That means it's just this. There's no actual motor tests. It's literally, can I get through my boot sequence, render some stuff on screen and click through the menu? And I'm going to skip through everything else. All right. Now what I want to see, just to refresh my memory here, is if we're in right, so we can set this. I want to see where, in fact, we're dealing with the pattern again from Stroke Engine. Just to recap my brain, make sure that I'm not going crazy. Draw play controls. Okay, you're setting up a bunch of wonderful things here, but from Stroke Engine, where do we set the pattern? And how are we going to resolve this issue? Let's go find all of our instances of Stroker, which I believe is the name. Let's confirm. Docs. Okay, find all the instances of Stroke Engine inside of source. That's not going to work. Go to rejects. I say rejects, I don't say regex, because I'm cool. You're cool too. You could say it however you like. Yes. All right, we're just gonna have to go classic way. From memory on where this is saved. Okay, so I believe it's underneath services, and I think it was underneath a file called helpers years ago, but I don't think that's the case. We're gonna go into Stepper and see, yes, okay, we instantiate it in Stepper, and for no good reason that I can see, it didn't come up in search. Probably a capitalization. Okay, so right here, init Stepper does not initialize the stroke engine. So we're just gonna go find stroker, hello, underneath source, yo. Are you gonna tell me this is unused? That would be crazy. That's wrong, right? Am I crazy or is it used in lib? Whoa, no way. Whoa, we need some linting in this repo. This is insane. If that's unused, my tiny mind will be blown. It is unused. What? No way. I simply refuse to believe it. Huh. Quick recap. Back into the function. Go over here. Stack size, wonderful. Back here. Stroker begin. Yeah. See? What? What's up with my search, man? That's crazy. All right, let me quarter second debug here. Ah, look, it comes up right away. Am I actually insane? Minimize docs, minimize this. Huh. Yeah, okay, maybe it was here the entire brain. Who knows, man? This is what I get for waking up at 5 a.m. But I'm doing it for all you North Americans. The previous two streams were at my convenience, just to see if we'd get them done. They were really fun. Truthfully, very fun. So I'm going to keep doing them. But they were very inconvenient for everyone else. So I'm starting to wake up at 5 a.m. to try to get these things done, work together. Make sure you can see what's up. And granted, all devs on this call are going to know this is a pretty slow way to develop. It's just better because you're involved. It's you and me hanging out, like I said. Good to have you. Okay, so stroke engine is here. Begin stroke engine. Great, great, great. Yeah, machine, servo, stepper. This is what I was anticipating. Good. This is where we pass forward the stepper. We almost certainly have modified stroke engine. Sorry, I definitely have modified stroke engine to accept these input params. I recall this. Good stuff. Brain, brain. Now, where is my pattern? Start pattern here. This is where we have to, so if state is ready, just want to see where exactly we're changing the pattern, which I believe is occurring, because this is going to be another area of the code that breaks critically. So where exactly is this break occurring? So we're going to go back to draw pattern controls. We're annoyed at this. We dislike it. It is what it is. Clicking through, clicking through. Where do we set the pattern? Next pattern here. Settings.pattern is next pattern. And then I'm presuming in play controls, as if I didn't write this code. But I presume then in the code that I wrote that in play controls, which we will find, consequence of having my coding repo here, or my coding program at 1/4 resolution, is I'm just going to search for literally everything today. Okay, just like this. But yes, just like this, click in. Okay, there we go. Where are we updating the stroke engine pattern? This is what's up. This is the trick. This is what we're gonna go find, because this is gonna break. So let's just go find pattern in here. Header text, thank you. Okay, this will also break. Yes. Data. Yeah, play controls data. This is not relevant because it's just a payload that is shipped to the page to draw. Yeah. We're gonna have to figure this out. But the current pattern inside of Stroke Engine is going to be a problem actively requiring a little help. I think we understand the plan. I think we get it. I think little file system is working. Let's go check in on our robot. Robot says, yep, claims there's nothing plugged in. That is a good error in the case of cursor, because cursor cannot maintain an active connection to a terminal. So we're going to go check. Let's go terminals run, crack this open. My pre-config terminals here. Let's go, PIO run. We're hoping for a little file system to upload and then print the registry file. That's the test we have in place. And then we're going to build all of our broken code, or like build solutions to all of our broken code in the way that we described. For the sake of speed, we're going to do what I've been talking about. So we're going to have built the solution, or know the pattern for the solution we want to create. And we're going to ask Cursor to deliver on it by being very specific. We're going to treat it as a thing that can type faster than us with better syntax, quicker, just like can more quickly recall the syntax. But the dumber we treat it, like we state to it, like, you have to do exactly this, you must do this. And the less freedom we give it, the better it performs. It is absolutely my experience that it is not an independent contributor. It is certainly far from that. It is an over-caffeinated junior developer, eager to provide something, perhaps intermediate developer now if you're doing 4.6, like Cloud Opus 4.6 and everything, which I do. But yeah, I don't trust it. I don't trust it that much yet. I have trusted it. I have given it that much freedom, and I'm not ready. Okay, let's take a look. Let's take a look. What do we got? Registry file. Yeah, BLE. Sure. Clear homing. When is the registry file read? Because I want to see this during init memory, and I'm hoping init memory occurs quick. Init little file system. Okay. Is not called. That cannot be true. This must be the same search issue we had before. Or it isn't? Okay, it isn't. Unless init board. Let's go into init board, set it up there. Yeah, PIO, init board, hello. Yeah, what the hell? It's right here. Oh, I don't know what's up with my search today. It's driving me simply up the wall. Huh. But yeah, I can find it here. Okay. We will leave it be. It's working now. Let's go make sure that we have enough logs in here. So ESPI information should be above our log level. Let's go check. I don't see logs associated with this, so we're gonna go debug level one more time. Okay, memory heap failed. I want debug level. Info level should print. I just don't see it. So I'm wondering, just want to triple check we're absolutely working in the right part of our workspace. Yes, confirmed. And CD, ls. I mean, yeah. This is all correct. So we're going to do this again. But we're going to have a 500 millisecond delay at the start of this. Tell you what, I 1000 millisecond delay if version dev. If dev, not debug, but thank you. I don't think it's debug. Let's go check. If def version dev. Okay, 3, 2, 1. Ba, ba, ba. PIO run. And then pretty soon I'm gonna have to go find my my cable for this thing. The goal is we want to see motion on that damn machine today. For 6 hours in from previous streams, 7 hours including this one. Gotta have some motion. I gotta see a thing move. That's what I want. Okay, uploading. Okay. Timeline here. So we got 2 hours and 20 minutes until I'm gonna go meet a friend for coffee, and we're gonna talk about the Chastity lockbox. She's a cool person, developer, PM from Vancouver, living here in Thailand as well. And she had a really fun idea. Okay, let's just check this. Initializing partition read parsed successfully. Okay, wait a second. That's wonderful. Parsed successfully is exactly what we want to see. Yeah, beautiful. Yeah, she's got a fun idea that she wants to see if she can work on with R&D. The Chastity lockbox, if you don't know it, it's another R&D product. This one specifically is for gatekeeping access to a Chastity key for long distance partner play for Chastity and whatnot. Her fun idea is a check-in app where you just have to do constant check-ins. That's it. It's that simple. The joking title she gives it is the stalker girlfriend app. We're just gonna have some fun and chat about it. But if that comes into the ecosystem, I'll let you know. You'll hear about it here first. Okay, MQTT connected, cute, love it. Memory, y'all, wonderful. We're just gonna do a quick thing before we move on, is we're gonna do a bit of safety. We're not gonna care about that. I'm just gonna leave a note. Odds are most people will not have the registry. Not have a registry file. Okay, the only thing I really want to see though is the contents of the Arduino JSON. So we're gonna do print the Arduino JSON to log. Yep. I want to do it if def version dev. Yeah, sure. We'll take it. Let's go. One quick rebuild. Has no member C string. That's because we have to do string, JSON string. No. We want to serialize, baby. Serialize JSON. Thank you. I don't know what is going on here, but a friend of mine and I were chatting. He's a dev. He said that recently he's found AI making more obviously wrong mistakes than ever before. Serialized JSON. Am I the AI? Did I make the mistake? What's going on? Expects 3 arguments, 1 provided. Well, what are your 3 arguments? Buffer size. Ugh, but I don't wanna. All right. There is a string version. Target destination is, I'm just now curious how they're doing this. So they do a template function, type name t destination, which is a pointer, cool, of type t destination value of the pointer. Detail enable if t is in. So if the pointer isn't it, sorry, if the point, woof, let's go through this. Totally unnecessary. This is a full sidebar. Oh, hey, Lucy. Awesome rebuild is finished. I think we're gonna have something in playtest soon. I would say for this, for the live coding sesh, that's a good question. We're gonna have motion today, and for the live coding sesh, I'm gonna see how easy it would be to get everyone going. I think it'll be pretty easy, in fact, because if I go to docs.researchanddesire.com and I go to the awesome web flasher, which is underneath tools. So right here is the URL if you can't see it. It is awesome/tools/web flasher, but you can find it on the left by going to awesome and then going to tools. You are going to be able to see my development branch called, oh, I don't have a PR. I'll make a PR. And then when I make a PR, you're going to be able to see my dev branch specifically for this feature, and you'll be able to flash it to your device. The only stipulation is I'm going to need to release this onto, release the dashboard code into production for you to be able to see it. And it's low risk. So I think that's acceptable. Long story short, yes. Yes, you're going to be able to do a bit of a playtest. I will target a playtest and I'll put it here. Let's target a playtest within this session or by end of session that is installable by semi-technical users. So let's give you an icon. Let's give you a little to-do icon. What do we have for play test? Nothing. What do we have for play? Great. We are not doing a child. Oh my God. Children at play, also not happening. A kite card. I don't like any of these. Quick vibe, flying through. Walking the dog. Doesn't sound like an innuendo. We're gonna find something, Lucy. Find an icon that feels like a playtest. Boogers? Could be wet. Could be a splat. No, no, okay. I gross myself. Heart emoji. I'm down. I'm down for heart emoji. What about heart emoji. That's anatomically correct. There you go. All right, we're gonna do user playtest. Unsafe code. Unsafe as in super early access. We're going to be installing dev branches and working off production code that is like expecting you to be on a dev branch. This is the vision for sure. And we're going to do goal installable today. Question mark. Question mark implies. Please don't send me angry emails if I miss this. That's the dream. But if you see this, this is about the playtest. And let's go with a color. Let's go. Pink. Yeah, we'll go orange red. A little Reddit styled. Ah, boring. We're gonna move on. Red. Okay. So we have our Arduino JSON. We're doing our dumb check. Well, thank you, sir, for the free usage. I ain't using it. Composer 2 is acceptable. It's fast. They have doubled our usage for the weekend. Thank you. But Opus 4.6, man, it's really good. Composer 2, you're not going to touch it. Yeah. I'm burning through tokens, ruining the environment. There's no justification. What can I say? But there's a chance. Oh, what is that? Who's Basilisk? We're gonna find this really quick while we upload. I think it's there's that Basilisk. Oof. AI Basilisk. Come on, story time. Ah, Roko's Basilisk. I think that by using Opus 4.6 exclusively, I am supporting our AI god known as Roko's Basilisk, which is that super future godlike AI that this person who wrote about this conceived of, where it's so intelligent, so powerful that it's going to be able to look back through all of history, every log that was ever created for any digital record or DNA record, and it'll be able to determine from these records who supported its existence, who supported the development of the creation of this god, Roko's Basilisk. Is it the name of it? Of the god itself? Don't know. But by using 4.6 exclusively, and rapidly accelerating the destruction of the environment, I think I will live a good life in this future if Roko's Basilisk's theory is true. So that's my justification for not switching to Composer 2. You should do the same, I guess. All right, let's go take a look. Did we get our registry JSON with content that we find usable? Yes, brilliant, right here. We have our patterns. So next up, this is where we're going to tap AI a bit. But again, do not do. Strongly recommend, professionally and personally, do not just give free rein to your AI. It does a bad job. So let's go be very, very descriptive, reasonably descriptive, but not so descriptive that we're just writing the code ourselves. We want to be fast. MVP vibes. Okay, so plan mode 4.6. Check to see if something better came out. Codex is okay, decent, but we're loving 4.6. Here we are. Bum, bum, bum. Let's pull in our raw notes, and we're gonna have to improve these because this is not good yet. Hey buddy, how's your weekend? You sleeping all right? Got to check in with the thing, you know? Okay, let's leave that there. We're gonna be adding dynamic. Let's not say the word dynamic, it'll get confused. We're gonna be adding patterns to stroke engine from the registry.json file. This is going to require a few changes. Okay. So first things first, the current stroke engine patterns, patterns are here. Let's go here. We got to dig through, just make sure it knows. It's underneath lib. Da-da. Okay. Quick navigation thing, because when I started Platform IO, I mean, I wasn't super clear on these either. So, excuse me. Source is obviously your source code. Lib is code that you control that you want to install as a dependency. Include is code that you do not control that you want to install as a dependency. That's the breakdown that I use in this product. That's what makes sense. Does it align with these READMEs injected by Platform IO? Who knows? But it's sufficient for me. So stroke engine is code that we copied in and have heavily modified. So we control it. Obviously, we keep the license here, respecting Elims, who did exceptional contributions, and the team over there. Anyone who did anything on that great open source project, which is the backbone of the awesome today. We want to make sure that they get the credit. We are forked, it seems, from the 2001 version, or 23 months ago at the very least, with significant modification. So she lives here. We have these patterns. These patterns are hard-coded. We're just going to pop in some of this information. So current stroke engine patterns are here. And in the stroke engine play mode, we draw the patterns menu here. So we're going to go find, draw pattern controls, give this bad boy a lot of context. Really, truly, just think of it like, I mean, we're all experts at the shit now, but just in case you're curious how I deal with it, treat it like an ambitious employee. Just need some guidance. Okay. So we draw the pattern menu here. As you can see, we limit the encoder value to be equal to the size of the list, size of the enum called, we found that as stroke patterns. Let's go find enum here. Class enum, love it. Ba-ba-bum, stroke patterns. However, this won't work anymore because the actual size of the list is going to be all of the stroke engine, all of the hard-coded stroke engine patterns plus all the registry.json patterns. Cool. Delicious, which could be zero. Be zero or could be 100. Yeah, we talked about using an STD vector for this, which is less efficient than something like an unordered map, but we are not going to concern ourselves with too much efficiency yet, unless it's memory efficiency. We are so sensitive on these devices to memory efficiency. Oh, there's no way you saw that on that camera, but I destroyed that mosquito. Oh, satisfying. Okay. So it could be zero, could be 100 patterns. Taking off the bracelet for a sec, just get a little bit more leverage. Likewise, we have a list of stroke engine names. Now, names and descriptions. Here, that is in UI strings, stroke engine something. Yeah, stroke engine descriptions. I mean, like, we also have that thing that I just saw, but let's go. Well, at the very least, okay, what I'm concerned about is all the hard-coded things which are in progmem. Quick, again, minor memory tip for whichever developers are out there right now that are just working on their own project. Who knows? Maybe it's a fork of the awesome. sidebar. If it is a fork of the awesome, please merge stuff back in. I love you. And if it's just your own cool ESP32 project, progmem, please, dear God, progmem your strings as a static const char. You will save yourself so much headache. Don't do anything else. Okay. Here we go. Okay, so here we have our descriptions. Obviously, this is also insufficient. It is also insufficient. Because we need to include all of the new strings from registry.json as well. Okay, so we're going to give it context here on and then we're going to give the solution. Again, anyone joining, the objective here is to code fast, but tell it what to do, tell the AI what to do, and not let it just do shit. It's an employee, not a genius, and in fact is very dumb. So here are the solutions we want. We want on boot during the init board, the init memory function. Let's just add that. Hey, where's my, oh, it's called init little fs. Hello, is my index not? We'll just do memory dot cpp during the init fs, little fs function. I want you to determine the total number of patterns, construct an efficient array of the pattern names, pattern descriptions, and in the case of, we don't care. Yeah, we only need pattern names and pattern descriptions, such that the hard-coded stroke engine patterns come first in this list. Then in draw pattern controls, we want, and let me tell it, in draw pattern controls, man, what is up with my indexing right now? Can't search anything. You know what it is? I don't know why I keep forgetting this. It's the dang stream. That's definitely it. I keep forgetting that it takes energy to do a stream. So this is the consequence. So in draw pattern controls, this function, we will then show the names and descriptions and info for all patterns, where if the current pattern is in the range of the enum, of the stroke engine enum, stroke engine patterns enum, then we do a traditional stroke engine pattern. Like initialize init a traditional stroke engine pattern, which I still have to find that code. Else, just temporarily use stroke engine simple penetration, because we got to figure something out. Plan out the motion controller, which is what we're going to do while this AI churns over here. All right. Is that sufficient? Let's go check. draw header text. Yes. Yeah, check all places where the stroke engine count or string for stroke pattern name is pulled or used, and update it to this new system. When in doubt, use the extern pattern to make objects global and, in air quotes, singletons. Not exactly a singleton. I think there's a chance it literally is a singleton, but this is one of those pedantic things we're not going to worry about too much. Anyone who wants to check in chat, who wants to be pedantic with me, can tell me the correct definition of a singleton. And if in C++, are we creating singletons when I do extern to define a global? That is not a thing. I'm going to pause to answer now. Okay, let's let this plan. Let's go talk about it. I am more interested in the motion controller. So I see numbers increasing for folks jumping into chat. Hello, hello, and I love you very much. Let's go. We have our pseudocode running in the background to fix all of the issues required for pattern drawing and loading from registry.json. The thing that we're talking about now, so let's just make sure we're talking about our blocks of work. We are successfully loading patterns from memory. That means this hat is going to change. We, for those who don't know, are using the hat system, a classic hat system for understanding our current state of work. If you've not heard of the hat system, that is on you. JK, we invented it because freeform has no icons. So yes, we are happy with the fact that we are reading patterns from memory using registry.json and little file system. So this is upgraded to the MVP ready, but not ready to go outside, where outside is production. Now the top hat is things that are in progress. Yes, so we are working on this one right now. So modifying stroke engine to allow custom patterns to show up in the pattern menu. This is the thing that we just did all of the code reading for. So we dug through the state of code to understand what is required to change. We've asked AI to do it, not because we can't, but because it types faster than us. And this is the perfect place for AI. We just told it how to implement it, and we'll go read its solution in a second. So the thing that we're going to work on next is we're going to start talking about and planning our motion planner. That's here. This is our next state. I have a spline and I need a set of commands. All right, we're going to take a second here to see what the AI says, and then Age is going to take a little water break. We are also going to add a block of work as a little heart. We're going to assume, we're going to change the definition of this heart here a little bit to, we would love this. Meaning it is something we're going to target. It's something we think people would love. It's something we think we would love. Let me update that. Make her a little small. Ba-bum, and red. Now this seems aggressive. Pink. Ah, the other one's pink. Red. Okay. There's a heart. Okay, so we have over here now, we have a design based on our or a plan based on our input. Oh, cute. Okay, at the top, as a joke, I said, "Hey buddy, how's your weekend? You sleeping all right?" And he said, "Oh, weekend's going okay. Thanks for asking." Didn't tell me how I was sleeping though. But I wasn't really expecting that. That's cute. Okay. Cool, cool. You've got a plan. Let's read your plan. All right, there are 7 hard-coded stroke engine patterns defined in the enum. Wonderful. Correct that we are loading from registry.json. Yeah, not consumed yet. That's okay. We just get the Arduino JSON file. Cool, cool. Okay. So the plan is to change this from 0 to 6 up to any range up to n. where the stroke patterns enum stays for hard-coded. Yeah, correct, but we don't want to keep it. But we want to change this. So data structure. Create a new file called pattern registry that owns the merged pattern catalog. We are okay with this. Yeah, but why have the Arduino JSON file if you're just gonna have this? I think it's okay. We'll just ditch the Arduino JSON later. I do prefer to have the std vector. It is ordered, it is indexable. It has STDs. I know, it's such an easy joke, I'm sorry. Okay. Iterate through registry. Yeah, pushing each name and description. Yeah, it's a copy. And set the total here. File changes to settings percent. Yeah, hard code and pattern count. Can you not do this, dude? Can you just like, ugh, this is a bug tomorrow. The fact that it wants to hard code the pattern count is a bug, just not today. It should just do size of. We're just gonna tell it, dude, do size of, please. Yes, it's runtime, but it's just okay. But realistically, is it going to be a problem? The patterns on Stroke Engine haven't changed in years. Okay, all right, gonna get off my high horse. MVP, we're targeting. I got an hour and 50 minutes until I have that coffee with a friend, so we're gonna forget about it. But I want you to know that I know that that's annoying. That's it. You know that I know. Yeah, rip hack jackhammer mode. Is that even in here anymore? I don't know. I recall there was something called Vlad the Impaler for a while. Yeah, flag it for a future fix. Yeah, flagged, verbally flagged. We're gonna send some AI through this to pull out all the things I gotta do. No, actually, for real, let's go flag it. Um, bum, bum. This is old, but we're gonna keep it for vibes. Let's go. Let's go make a like to do. Let's get an icon. Animal. Yeah, man. We need. Mm, need some kind of animal that implies to do. That sounds like it's an animal I want to do. So we're just gonna, oh God, we're gonna take a conversation I had yesterday with some friends, and we're gonna use that context for our to-do animal. I don't personally have this fetish. This is not my personal kink, but I learned that the Pokemon people most want to have sex with is Vaporeon. So the to-do icon will be Vaporeon for this reason. You can thank my friends for this information. I'm sure many of you already know. Okay, let's check. Old since removed modes went. Oh yeah, this is. I see what you're saying. So, folks can't see chat here, but Lucy just said that there was a mode called Jackhammer, which used to. I think we're talking about the same thing, which had a bug lovingly noted by the community as Vlad the Impaler, where it would go all the way in randomly. And so Elims just pulled it. This is very likely Jackhammer. Okay, so this is our to-do section. Show of hands if you personally want to do Vaporeon. That's total support for you. Love you. If I had to choose a Pokemon, would it be Vaporeon? I don't know if it'd be Vaporeon. I'll think about it. Maybe just Ditto. I feel like Ditto's like the most variety, you know? Anyway, to do. Yeah, Mr. Mime's cute though. Yeah, I ain't against it. Okay. So the to do thing I wanted is that we're gonna get the AI to do this, and this should be a size of or something more dynamic, just in case. Um, stroke engine gets old patterns back, and we don't want to have to hard code or update this one bug here. Clipping through, back over here. Pattern entry. Okay, so you want to add into pattern registry your new file. These elements, build pattern catalog, which merges the old and the new. I'm okay with this, even though it adds a file. It is separation of concerns. Yes, call that at the end of little file system, even if the registry is missing. Yes, good. Yes, this is okay. Instead of pattern controls, I am okay with the pattern catalog being used in this way. Good, good. Switch settings.pattern block handles in the enum cases. This is what I wanted to see. Oh, okay. Is this where that code occurs? Let's go check. Again, AI is not God. You are in charge. Let's go find out. So we're stating that inside of awesome stroke engine, because the code I was struggling to find earlier when we were doing our pre-planning was just making sure that I saw where the pattern switching occurred. But I'll tell you what, I still don't see it. I still don't see it. This is the file I was in before. Set pattern. Oh, okay, okay. Yeah, wait. In retrospect, this is very obvious. Okay. Good, good, good. Totally fine. Potential bug here, though. We're going to check. So the switch handles the changes. Good. It's doing a limiter to see if it's less than the hard-coded pattern count. Example A, where this could become a bug in the future. If it's not computed at runtime using size of. Okay. Cast to stroke patterns, the new thing, and then run the existing switch. Okay, yeah, the old thing, sorry. Else, we're using a registry pattern, which is just going to set stroke engine temporary placeholder down. Okay, good stuff. Play controls, you'll change the names. Thank you. Pattern 0, static cast. This is total pattern count. Yes, okay. So currently this was casting the limited patterns, which pattern you could be on the pattern menu based on the enum, but we're going to do something different. But cast int, okay, we'll just leave that for now. It might make some trash, might do some garbage. Loop over the names with loop over pattern catalog for communication. This is going to implement something that was a unicorn for us. I'm glad it caught it. So our unicorn from our plan here, I'm going to change to a golden hat, which is modify the characteristic for reading patterns. Okay, so context, the radar and other Bluetooth controllers like the Research and Desire web controller, these query the awesome and ask it, hey, what patterns do you have? The reason it does this is because I'm a genius with foresight. No, in fact, I did actually see in the future that I wanted to have a dynamic pattern list. So I intentionally made sure that there was a request protocol for getting the pattern names and descriptions from the device for a feature like this down the road. This thing that we're working on didn't come out of thin air. It has been primed by me and the team for a while. It's something we love. So yes, this is good. Okay. This guy's gonna MVP. It is in progress. It's looking good. And update comments in the loop to reflect the pattern, blah, blah, blah. Okay. Call flow, we'll say, you can't see when I zoom, of course. Init board, init LFS, sorry, little file system, parse, build, push. Okay. Then call flow. Okay, I think I'm down for this. We will attempt with, we'll experiment with removing this next patterns thing for the record. But yes, let's go. LFG, bro. Build it and make me look good. All right, we're going to do a quick water break while I go find the motor cable. So we're going to post a notification to the folks. We're going to find my notification section. Where are we? Da-da-da. You know what? I'm going to go top down. Kind of losing track here. All this content. Come down here. Going vertical. Vaporeon, you can stay at the top. Your to-do list. You're here. That means... Dun, dun, dun. Okay, we're going to go to here. Okay, so here we are. For anyone who's showing up, we're doing an MVP of pattern drawing, part 3. And AJ is a thirsty boy. And it is missing a few wires. Both facts. BRB. Yeah, I should be back in whatever your time zone is. So XX 25. So your time zone at 25 minutes, unless you're in one of those countries that has a time zone that ends in 15 minutes, like a 15-minute different increment, like Iran. I don't think that's likely. Okay, BRB. And we're going to plug in something. We're going to plug in this. Okay, back in 5. Okay, still missing some wires. But I think I know where they're at. Oh, we hope. We hope for that motor ain't moving. Okay. The wires yet. So we think. Probably here. Yeah. Hey, oh. You know what I found too? I found a USB-C to C cable. What I was complaining about before. Okay. Hello. Want a remote? What the hell? We got it all. Okay, cool. What else do I want from here? Bunch of good stuff. I want this cable. I want. I have a gift for you guys. Do have a gift. So many little gifts. Okay. For now, I'm gonna save this other secret gift. For now, I'll pull out my tuna fish. Look at this little guy. Look at him. I don't know. He's for content. So I got him for awesome related content. I have no idea what. I just saw him and I thought, fuck, that's great. That's something. He's a purse as well. You can unzip him. Maybe a pencil bag, but purse. All right. It's my little gift. You can enjoy hanging out with our fish today. Okay. And then we need electricity everywhere. Check everything. We have electricity from user. Okay. Folks, I have a dumb question. Can 35 watts power the awesome? Let's go. Somebody can answer in chat, but I think no. I think we are a 60-watt machine. We're gonna ask the robot here, see what's up. Morning. And 35 watts. Power the awesome. Huh. What would be the risk of me doing this? Using the low power thing. So I have two chargers here. One's the MacBook Pro charger, which absolutely can power the awesome. I also have this battery bank, which can absolutely power the awesome. It's great. What I don't have is power on the battery bank. This is a big fat 00. No, 120 watts. Yeah, okay. I mean, I was kind of expecting that it would say no. I was hopeful. Maybe we do try just for fun, but let's not waste our time. Okay, so I'm going to. What am I gonna do? I want juice on the awesome. I'm gonna do a disgusting daisy chain. Will this work? Maybe that won't work. Okay, what can I do? We're gonna power the charger for a little bit, or power the brick. Try to get some juice on there. Let my MacBook die. While that loads up, we will get awesome going for real, for real. And yeah. If anyone's hanging around, you can tell me about your weekend, what you're up to. Anyone got any super cute plans? Always interested in super cute plans. I personally had an extremely cute weekend last weekend with all my friends. I posted a nice reel about it on my personal Insta. I don't think anyone has access to my personal Insta, but if you find me, try not to dox me. Love you. I'm not really hiding, so you can find me. Please don't. Just kidding. If you do find me, let's get a coffee. And the super cute weekend was just so many nice things. We went bike riding and hanging out in the park and hung out with some snakes, like held snakes for a while, art galleries, and all this just lovely stuff. It's a good reminder. Hey, I don't know if anyone here needs to hear this message, but if you're a programmer introvert, go outside, talk to your friends. It's easy to forget. It seems weird to say, but it's easy to forget how absolutely essential it is to do human contact. That sounds insane, but it's true. All right, we're going to wait for this to charge just a little bit more. We cannot power it with 35 watts, so we are still a thirsty boy. Water's right there. And then we'll power on the Awesome and start messing with the motion controller. While this charges, we'll probably just do a little bit of that motion controller design plan to make sure we understand the objectives and things make sense. Hey, camera one, sorry, you're going to fall off. Okay, there we go. Camera one returned. 3, 2, 1, camera one. We're gonna see. Gotta check OBS. Trust issues. Yeah, no camera one. All right, we'll leave it for a sec. Just needs a second to detect the device. We hope. She said hopefully. Wow, she said really hopefully. Still not there. Oh, hey, camera one. Welcome back. Motion planning design. That is what is up. So let's talk about it. Let's get a little discussion going. I want this laptop closer, but I will just buy a longer USB-C cable next time. Oh, the consequences of our choices. All right, so time check. I have an hour and a half. I want to get to a good stable state where folks can install very unready code, but install something and have a bit of fun. Join in with me. So we got to make sure we're working for that objective. Finger over here, on my face, sir. Thank you. Just thinking, collecting my thoughts. Give me a sec. Okay. Thoughts are collected. Let's talk about motion planning just a little bit. Yes. Yes, there are extremely well-established motion planning tools. Fun fact, I'm doing a great, very recommendable motion planning course. I think it's hosted by MIT on YouTube. Really recommend it. All of it is too advanced for the Awesome so far. Meh, all asterisks. So we're not doing that level of motion planning. We're not going into, inverse kinematics and all this design. What we're really just trying to do is we're trying to take a cubic spline, the curve provided, which in this case, for demonstration purposes, is this, but let's go with something a little bit more plausibly realistic. Let's make some choices on how we want to break this up. Define the risks, and we'll outline the solutions. Down. Here we are. We have a curve. This curve, we know, is modulated by these variables: speed, stroke, depth, not sensation. Not yet. We have ideas noted above, noted in previous videos, but we have decided to pull them from today or from the MVP. So the real question we want to ask is, from a given spline, how do I determine the commands to send to the stepper? This is the question. This is the conversation. the risks are 1, overwhelming the stepper. The stepper motor position cue, to be clear. Command cue. That's issue 1. Oh, what? Sorry, parallel. This guy didn't exit agent mode? All right, that's annoying. Get back. Risk 1 is overwhelming the stepper motor command queue. Risk number 2 is sending so many commands that the trapezoidal motion pattern, which is on the stepper already, becomes evident. That the motion, I don't really know the exact terminology here, but I'll describe what I mean and somebody will tell me the word. Motion planning system, what's the word? The trapezoidal thing. Motion system on the stepper becomes evident. Evident. So this is the case where if on this curve, excuse me, in fact, it's really evident if you do something like this, where you have a line and then you send commands like this. Let me get an arrow or a circle or something. If you send a command to go here, 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 and here, I mean, like, you just get a really choppy output, when in fact what you really needed to do is you really just needed to say, I want you to go to the endpoint, the last one. So there is a risk that you can send too many commands, that you overwhelm the stepper. There is a risk that you send enough commands to do the right thing, but that you show or reveal the trapezoidal motion system underneath all of this, and it becomes choppy. So this is a choppy example, and this is a good example. All right, so what are the parameters of a spline? What else is a risk here? So we've got to be a little decisive. It's always good to ask the question, just how would I solve this? Seems like an obvious one, but what is the easiest approach is the first question. So the easiest approach, MVP thinking, because there's a right approach where we do slope analysis, maybe a little curvature analysis, and we figure out when we're in a case where we want to reduce the number of points being sent to avoid this choppiness. That is tempting. I don't think we're going to do that today. We're doing minimal slope analysis because it falls under validation, which we are also not doing today. So the easiest damn thing is to just do this, is to do the choppy pattern, which will be bad. But let's take a look. So if I have a cubic spline, I'm just going to set a beat and I'm going to compute the target at that beat. That is the easiest approach, which is deliverable MVP today. It is bad for the reason mentioned above. Do the choppy thing. Okay, so that means that we are going to set some kind of clock, and this clock will bum 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 at a regular frequency. Pick this up. This introduces a new problem, which we perhaps don't have a solution for yet. Let me show you. Because this is a speed modulated curve and we are setting a frequency, this means that if we reduce the frequency of this by increasing the speed, you can see right away. Let me do a less extreme example. So like, cool, this looks good, but we're taking a beat, a heartbeat, to determine where we should be on this curve. Nice, looks rad, but we're not changing the frequency of that heartbeat. Rather, we just determine in advance, okay, well, this has to be here, and this has to be here, and this has to be here, so we change the speed. Looks great until, yeah, there's a lot of computational geometry stuff out there for simplifying splines. Yep, for sure. But we're just going to go easy there, Lucy, because the thing that we want is not necessarily simplification. It is good sex. And so it is a different request. This is still not indicating the problem that I want to show, so I'm going to do one more example. We're going to go a bit more aggressive. This is a good example of what I want to show. Okay, so this is the risk with this heartbeat approach. We have just hit an example, an okay example of a Nyquist frequency on this pattern, where it now looks like a totally different pattern. The features and qualities of the pattern that were originally there are now not present. So this is the risk of the heartbeat. This would be here. It just looks totally different than expected. We are going to accept this risk for the purposes of MVP. It's more than a risk, it is a certainty. Like, this is just simply not the same profile. So the thing to do, well, we already have solved. In the validation step, we determined how close 2 points could be given our max velocity so that all motions drawable are also playable. We've determined these numbers, they're above. Quick recap, somewhere here. We go up. Great questions from folks in the community. Yes, okay, so if we force that 2 points can at closest be 0.01 time units, not seconds, time units. So that is a 1% closeness in our time coordinates on any given drawn pattern. And if in that 1% you choose to go from 0 to 100% in the y coordinate, the position dimension, so 0 to 300 millimeters, which again is not all awesomes, then we determined that given the max pre-programmed speed, not measured, which again is not all awesomes, then our 0.01 time units is 0.3 seconds. So we're stating that in 0.3 seconds, in an ideal world with no deceleration, we can traverse 300 millimeters. Okay. So is this going to prevent this problem? Yes. If we have this limitation, thinking through this. So if we have the limitation that points can be no closer to each other, that is, two chosen coordinates can be no closer to each other than 0.3 seconds, let me confirm that number, make sure I'm not crazy, then we do not have to worry about Nyquist. We don't have to worry about picking up the wrong frequency. Asterisks. Because we still do if we shift or like desync a little bit. But if we're faster than this, if the heartbeat is faster than this by a factor of 2, then we should never have this problem. We should never see the wrong profile being played out. Okay, so we're going to make that statement. Factor of 2 is probably sufficient. So the heartbeat rate, based on our previous calculation, so assuming rail length is 300 millimeters, assuming points are no closer than 0.3 seconds in time, which is 1% time unit in the drawing tool. In case it's not clear what I mean when I say time unit, because this is scalable in time, you can make it shorter or faster, shorter or longer, right? It is not actually time that is being represented here. It is a function of time. Just like think of your classic sine waves from trig, nothing crazy, just same sort of thing. So since we're stating that points are no closer than 0.3 seconds in time, if the heartbeat is, we're going to go 0.1 milliseconds or 0.1 seconds, that is 10 hertz, then we should not have any frequency issues. Do we like this? Is this right? Okay, we're gonna have to determine qualitatively if this is good sex because that is hard to determine from these numbers. We're gonna say, yeah, the heartbeat is 10 hertz, major risk of number 2 occurring. So number 2 is this one, to be clear, sending so many commands that the trapezoidal motion system inside of the stepper becomes evident. That's choppiness. This is risk. This is good. We are not going to do good. We're going to do risk. We're going to risk being choppy. Yeah, we're going to accept it. MVP. That's the plan. So the heartbeat, we'll take the spline, chop it up, and go forward. All right, let's define exactly how to chop. All right, give me a sec. Just popping over here. Our little bro is done. So let's do a test on this, and I need a second to think about the chopping. So we're going to take a note here, poke a thread in this, pin a needle in this, whatever you want to say. So we must define how to chop our spline. That is a great song title for a song that never ever sells any records, but I like it. Oh yeah, we're running a bunch of parallel missions. So parallel mission is battery for awesome, which is 26%, sufficient for play. We're going to give it just a second longer. And coming back here, we have this mission, which is, do we see patterns in the list? So that is pulling us up to this block of work with this top hat. Allow custom thingamajiggies to show up, custom pattern names to show up from the registry. So let's go ahead and test that. What should I do so you can see this best? I think we're going to attempt this with the web controller and then also attempt with the real controller. So first things first, battery out. Plug this bad boy in. I need one more USB-C cable. I'll take it from light. I should just buy like 500 USB-C cables. I'll never have this issue again. Lucy, send me 500 USB-C cables, please. It'd be a dream. Oh God. Wait, you're the kind of person who would actually do that? Please don't send me 500. Please don't. Oh my God. I would be terrified. I don't know what to do with that. No, no. If you are going to, please make them cute. All right. Great. Like I've helped people in WeChat named Shenzhen Cable Vendor. Don't try me. Fuck yeah. Oh, I might run off to China for a weekend. So if you want me to hang out with any of your vendors, let me know. Just got a friend over there. Nothing crazy. Honestly though, Lucy, now I'm kind of tempted. Could you get like, could we get braided cables that say awesome all over it? I'm kind of tempted. Let's talk. We'll talk. All right, LFG. We're gonna flash. Unplug. Because the motor got a little stuck. I'll tell you what. I've been developing on the Awesome long enough that I know a lot of the failure modes, and the thing I want you to know, little story time, is you should imagine baby dev AJ. I mean, is considered a senior at this point, but I'm just starting working at Research and Desire. I have an awesome in the middle of Belgium, dead at night, and it's one of my first times working with this device, and I just keep slamming like at 2 a.m., 3 a.m. because I'm working remote, slamming the awesome into the hard stops, and it just keeps waking the building up. Honestly, I'm sure it didn't wake the building up. I was just terrified. I was yelping every single time, thinking I was ruining the motor. I've not broken a single motor the entire time I've been here. It's a goal of mine. It's a strong ambition. You want branded washable playmats? Hell yeah. What? Lucy, get branded washable playmats. Approved. All right. Menu task. I want you to see this. So we're going to try on the web controller because of course I can see the remote, but I don't have camera 3 set up. I could do it on camera 2. Let's try on camera 2. Okay. Let's try camera 2. Camera 2 is less pretty. Nope. Camera 2. Hello. Trust issues. All right. Okay, so camera 2. Click in. That's simple penetration. This is the hard part. I'm working with lag. So let me get OBS going. Hello, OBS. Okay, there you are. All right, let me exit, rehome. Okay, off screen here. I'm just going down to stroke engine, rehoming, which you can see here. Boom. Let's fix my apron. Bing, bing. Bing, 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 bing. Bing, bing. All right. We are in stroke engine, camera 2. Okay, hey, camera 2. Yep. So we're trying this together for the first time. Double click, enters patterns. I cannot read those, OBS. You're too small. No offense meant. Okay, zoomed in. I see more dots in the scroll. So we're gonna try teasing, pounding, robo stroke, half and half. Come on. Hopeful. Insist. Hey, test pattern. And test pattern 2. Let's go. Okay, when I click on it, test pattern 2. Hello. That's awesome. Okay, good stuff. Let's go back to camera 1 here. Let's go, yeah, camera 1. Let's pop in here. Let's try to show you the same thing on the web controller. So I'm gonna connect via Bluetooth, turn on Bluetooth. Bluetooth is on. Yeah. Radar screen is a good idea. Could grab radar screen. I will, in fact, do that. Sorry, Vaporeon. Get out of here. What? Request device. Give me a hot sec. I'm just gonna see if I can get this. Why? Do you think it's possible that guests in Chrome cannot use Bluetooth by Bluetooth? That's insane, right? I'm just gonna look in a different tab, which is not guest mode. Huh? Oh, no. Bluetooth is literally off on my computer. What? That's so dumb. Yeah, I will grab the radar screen because I'm curious to see if it works there too. And if it does, then we can check off one of our requirements, which is that we're one of our like unicorns, which is always wonderful. Hey, awesome. Pair. Yes, please. Hello, I'm seeing some stuff. Okay. Patterns. Look at this. Test pattern and test pattern 2. Test pattern for the awesome. Also a test pattern for the awesome. You see this? We have it. It's working. This does mean it will work with the radar, but for completion's sake, let's find my radar. Yeah. Give me 2 seconds. If we find the radar and we see the patterns appearing there, then we're happy that something's working. Yeah, sorry, camera. I don't know if I'm camera 1, but I get a lot of bloodshot right now. The thing is recorded. I'll put it on the OnlyFans. Low key, we should have a company OnlyFans where we just post me bending over during the streams. Oh no. Okay, radar acquired. I'm not sure which camera you're on, but I'll assume you saw that. Oh yeah, camera one. Hello, camera one. Okay, let's go. You're not gonna believe this, but I need a new USB-C cable. I'll take this one. Because you're dead, right? We're gonna see. Yeah, that's dead. Sometimes actually literally always, my dev code has a 5-second startup delay. So I have to just stare at the dang thing for a second, just to see if I'm the crazy one. Or if it is. Cool. UID parse. Oh man, awesome. Hello, you're awake. Let's go camera 2. Hello, camera 2. Man, bra straps. Gotta work on this. Somebody teach me. Teach me how to wear an apron. Okay. We go. No devices found. That's exactly not what I want to see, but that's okay. I have to open OBS because I have a 500 millisecond lag on the Twitch browser. Okay, give me a sec. All right, let's go back to menu, device search, searching for device. Come on. Yep, that's awesome. Click. I clicked it, but nothing's happening yet. Click. Oh yeah, I just didn't click hard enough. This is my dev one. It's a little messy sometimes. It's okay. All right. Brain patterns. Immediately. Look at that. You see that? That's test pattern 2. No icons, but that's okay. All right, so we are going to check off something from our blocks of work. Let's go back to camera 1. Hello. Hi. I keep forgetting to look at you. Sorry. I'm gonna get that AI thing that just like re-edits my head so I'm always staring directly at camera and you think I just developed like this. That'd be a power move for sure. Unless I told you about it on stream, then obviously a waste of time. Okay, so we have it on radar, we have it on web, we have it on remote, which means we're going to lock off this piece of work. So modify the characteristic that does reading patterns. Yeah, done. Validated on web, radar, remote. So we can see the pattern, we can switch into the pattern. Now we're in motion control. Motion controlling land. Okay, we have an hour and 4 minutes. And then AJ branches off to go get coffee. Because it is Saturday and I want to see my friends. So let's talk about how to chop a spline. What are the parameters of a spline? Specifically, what are the parameters in our context? And what are the conditions on those parameters? Let's go into our data. We've defined this above. We've defined this many times when drawing or building the drawing tool, which I forgot. I'm just going to show you quick. Localhost 3000. Which branch am I on? Almost definitely the wrong branch. So yeah, because I'm just receiving infinite logbox events, which is clearly AJ developing something else. Git branch, git checkout, clear, W quit, WQ, git status, baby. AJ has unmodified work. Am I gonna get stash again and forget it forever? Tempting. We'll get add commit. I don't know what I was working on there. So commit, add message, fix. Oh God, if you are a dev and you've seen the awesome repo and you've looked, if you're the kind of person who looks at the commit history, you will know when I'm there without seeing my name. I use the word fix so much with no additional context. Fix question mark, fix exclamation point, fix sad face. I don't know. I don't know why. It just became a habit at some point in my dev career to put the word fix in. I think maybe once I started doing team management for a telecoms in Canada, I was just like, no one's checking this but me. So the commits, not the PRs, all that, but like the commits. Ah, eh, squash merge, baby. Let's go. What is up? So I want to switch over to git switch or git checkout is fine. AJ slash awesome patterns. Did not match any of the following. Get branch, please. Awesome patterns right there. Did I spell? Oh, I spelled awesome wrong. That's funny. It's a 4-letter word. Well, it's just a fact. Got to do it quick because we have on the left here, just so you know, what we have running is the MQTT server running locally. We use EMQX in production. Yep. Yeah, you like to. Yeah. We are actually we do. Stephen, we do generate release notes based on the commits. Except instead of just using the commit message, we actually just load up full context of code changes. 2026 baby. So I just say, hey, here's the entire diff. What happened? You can check this out in docs. Actually, it's a little too revealing. Let me go show you. I will say I did use commits quite a bit. So what's up here? Docs dot am I not spelling things right? Just today. Okay. Yeah, so for all of our products, but importantly the awesome, because we're hanging with awesome. Forget this version 0.0. I'll work on that. But forget the fact that it's inversely ordered, but we do have auto-generated patch notes for each of these, which again is slightly too revealing because it's using the diff. So don't tell anyone, definitely don't tell anyone on live stream, but in products like Dashboard, you can see things that I don't want to be in there. It's not the end of the world. Like I reviewed it for security risks, but let's go in here. I think they're saving in different places because AI is chaos. Like I fixed the admin email search because it was broken. I updated React hook form to 7.71.2. Who cares, man? Who cares? Um, I'll eventually clean that up. But I'm with you, Steven. Autogen release logs, they're the bomb. Oh, did you change your thing? No. But anyway, I love you. Okay, moving back. Let's go back here. So we have this running. We got to do npx superbase db reset because this requires migrations, which might not exist. Migrations also could just be applied. Do I have anything in there that I want? I think it's migrations up. There's always a risk because one of them is against production and one of them is against localhost. But I think this is the one. I think this is the localhost one. If you're a Superbase user, unrelated, just like random factoid. Oh, localhost, it's up to date. Okay, great. If you are a Superbase user and you are still using the root level CLI Superbase, it is my personal recommendation that you start using the npx Superbase command. I don't know. All right, I kind of hate it because I have to write 3 extra letters, 4 extra characters, including the space, every single time to run Superbase commands. But it is nice. It is nice to be version controlled and to have the auto updates and all this. I kind of recommend it. You should switch over. Your team should switch over too. Just get everyone on it. We got everyone on our team to do it. All right, I want to show you localhost 3000 because I want to talk about the splines and I have to be conscious. I have 58 minutes. So maybe this is not happening right now, but pnpm dev, if it can, good. What I want to show you as this starts here is the conditions on our curves are, they are at least 3 points. Do I have this in here somewhere? I'm sure I do. No. Okay, perhaps. But I think it only went into the chat context, which next time I'm not going to do. Damn, I got a lockbox going crazy over there. Ignoring it. Damn, though. Okay. Solution. We are killing the Docker container for EMQX. Damn, that's insane. Noisy. Disregard. All right, pro@test.com. Let's try to figure out what those conditions were. Password 1, 2, 3. And as I will always say, Please don't DDoS me. That is not the password for any test accounts in production. That is localhost only. Don't try them. It's not real. All right. 99 notifications. Definitely from that lockbox spam. Damn, I gotta check out what's going on there. Okay, going into not tools, we're going into awesome patterns. Let's take a look. We have a bit of a slow load. This is definitely a stream issue as it was last time. We're gonna hope for the best. Oh, you know what it could actually be is just the spam I'm receiving from one of my real lock boxes that's over there on my bed at the moment. Let's go ahead at the hey pattern and talk about it. So we have 3 points, the conditions for a point, and we're gonna let it load in the background. I promise you you're not missing anything, it's just loading. Good old Next.js compile while streaming while connecting to other things. Okay, great, she's up. So this is our pattern drawing tool. You add and remove points. There's no validation, there's no safety, there's no concerns. Not C1 continuous, as you can see with the sharp peak here. These are the issues we will have to deal with eventually, not today. Today, what we have is a set of points with this sort of structure. Bum, 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 bum. This is our data structure. Wow, that's terrible. We're going to do a photo of our data structure. Excuse me, I'll take a half-ass screenshot. Okay. All right, this is our data structure. So every single point has an X and a Y. The X and the Ys are between 0 and 1. And the handles are not limited at the moment because, as you can see, they can go outside the bounds of the 0 and 1. We will eventually have limitations on them that are related to the min and max speeds and scaled by the speed. So we have these points. It is a strict requirement that points 1 and n-1 are identical. They are the same point. So that we have a cyclic pattern. Must loop around. So this is the vibe. Let's write these notes out to make sure it's clear, and let's talk about one. We need to generate on the awesome the function, which will provide us the spline. So we'll just go review our math on that. So the requirements are basically the only one we care about is 0.1 and n-1 are equal. And there's so much other validation we want to do. We're not going to do it. The C1 continuous validation, that's the shit that's not happening. So easy, just not happening. Throwing it out the window right now. Our test pattern, which is a triangle wave, is not C1 continuous. That's why we're not going to do it. It would invalidate our very first test. So, is what it is. Okay, we're going to set our heartbeat to 0.1, so 10 hertz is the heartbeat. We'll send commands to the stepper, which means the questions then are: one, how do we draw the compute a spline from data? Two, there's only one question at time t. Okay. So this is absolutely one of those things you could just ask AI on, but let's not rest on our robots. Let's go check computing the value of a spline. Spline at time t. Let's go jump into, give me a Stack Overflow maybe, sure. Give me a wiki. I'll take a wiki all day. Wiki math, baby. She got my degree. Okay, spline is a piecewise polynomial interpolating. But yes, we are going to be doing a pure version that does not have these loops, and that's okay. We just want the deets. So for a subinterval, right? Okay, so we're gonna have to have subintervals between points, implying sorted list. So we're gonna just note this as a part of a validation. So one subintervals between points. implies they are sorted. That means to say x being our time coordinate or time-ish coordinate must come after, sorry, x equals 0.5 must come after x equals 0 for subinterval computation to work. That is fine, but yes, we must determine our subinterval. And then within our subinterval, what is our computation? What is our function? If we're doing cubic, well, here you're going parametric curve, which we don't care about. That is too fancy. Suppose the intervals are here and here. Suppose the polynomial. I mean, should we just be silly about this? No. So the debate I'm having in my head is, what is the value? What's the cost benefit here of me just asking the AI to do this? So if I just got the AI to build us a thing that made sense, it would be doing the thing that I really hate AI doing, which is driving. Not a fan. So we're going to move on. The most common spline is the natural cubic spline. Cubic spline is 3 degrees. And continuity C2. We technically only care about C1 because we're okay with setting discontinuous acceleration, even though we absolutely are going to be C2 continuous IRL. So yeah, sure. Cubic spline. This answers my question from before. A natural cubic spline is what we're using. C2 continuous. Brilliant. Okay, so postscript. Okay, general expression for a C2 interpolating cubic spline. Thank you, darling. That's what I'm looking for. Okay, so we have for subinterval I at point x, z is equal to the second derivative. Well, that's 0. That's interesting because we're setting constant. Oh, that's very interesting. When you say I is not, you're talking about the intersection thing. All of our z terms are going to drop out. Okay, let's just roughly understand it and then get AI to do a portion of this because I have 49 minutes till I got to drop for coffee and I want to get to a point where you can test. So if I'm understanding this right, because we constantly set, because we're setting constant acceleration, air quotes, technically, this is constant. Interesting. Okay, let's find another reference quick, and then we will get AI to do this. What I want to see is we are landing on cubic, and we have handles. So given 2 points of a cubic spline, and their handles, how do we compute the function? The function between them. Yes. I just don't want to read this. Okay, I'll read it. Okay. To compute the cubic spline between 2 points with specific handle-defined slopes, derivatives d0, d1, use the Hermite cubic polynomial. The formula defines path typically parameterized by time being in 0 to 1. The formula is ft is h0 of ty 0 plus h1 of tm0, h2 of tm1, h3 of ty1. For these 2 points, 0 is start, 1 is end. The handle slopes d0, d1, assuming not broken, I assume. No, that should be sufficient. It's okay. Parameter t, usually normalized so that t equals 0 in the first one. Yeah, okay. Cubic formula, yes, that one formula. Fun. But where did our d terms go to, sir? Okay, m0 is the scaled tangent. And m1 is the scaled tangent. Okay, so let's just understand this briefly without having jumped into the code. So I think, or sorry, jumped into the originating definition. So what I'm seeing here is, I was hoping to see the implication. Yay, yay. Let's do it. Let's do it. I'm with you. Let's just jump right in. I'm with you. I want to get this done to a usable state. So I think I understand it sufficiently and we have a formula that I'm comfortable with. I'm going to open up your links here, Lucy, because I am with you. I don't want to spend this stream. I do want to read these articles. I don't want to spend this stream reading these articles. So I agree. You're right. Feed the shit to AI. LFG. We like our formula. We understand it minimally. Let's move forward and fire hydrant, fire hydrant, fire hydrant. Oh. Oh. I thought it was really good at determining fire hydrants. Yeah, LFG. Thanks for the check there, Lucy. It can be boring to stare at somebody reading Wikipedia. Oh my god, am I an AI? Am I a robot? Why? Why? Yeah, I know I'm guest mode and all, but like, damn, do I suck at these? Yo, I swear, I'm pretty good. I think. Hey, get out of here, man. I get it. Yo, what's going on? Oh my god, I'm gonna give up very soon. I have been flagged as a certain AI, and they're using me to train. They're consuming my tokens right now. LFG. Okay, here we go. La la la. We know the plan. We're gonna go in here. We're gonna say, heyo. Yeah. Uh-huh. Where are we gonna put this code? Let's think about how Stroke Engine is working and think about the easiest thing. We're gonna, okay, we're gonna make a new concept. So if a pattern is chosen from the registry, then it is going to be a cubic spline. Going to be a cubic Hermite spline. Okay. For convenience, we're going to post these links down here. Sorry, you can't see, because I'm in the one where it does not think I'm a robot. And we're going to post our computation formula that we received from this AI, just to make sure. Okay. Yo, that sucks. Okay, is what it is. Apparently you cannot copy latex out of Google. And again, latex, people would tell me is wrong, but I'm going to say latex, or latex instead of latex. Copy .html. Totally fine. It'll work it out. Where all this shit is true. Let's see if you can parse that. Good luck. Okay, good luck, dear robot. Dear God. What am I sending to you? So many SVGs. We'll cut that. Where delta t is equal to x minus x0 over x1 minus x0. M0 is equal to D0, x1 minus x0. M1 is equal to D1, x1 minus x0. Okay. Chill, chill. Let's go back up to the top and tell it what's up. Okay, that's going to be a cubic Hermite spline. This is a new concept. New concept where you must make a new class which receives and initializes one of these patterns from the registry. So the request would be, so here's the request. Request, given an index, find the ID from the registry for this chosen pattern, pass that ID into this new class called just cubic spline or spline pattern. On init, read little fs at this point, at this path, should be patterns slash id.json. Here are some examples. Ba-bum, ba-bum, ba-bum. And then store the critical information. Critical information about this pattern is properties. Properties, which we can access later. Access later, the most critical of which is the cubic spline itself, which we may choose to rename to spline, but for now it's fine. Spline data itself. So here's the thing we need to do. Given got to think about this a little bit. At a regular beat, specifically, every 0.1 millisecond, every 0.1 seconds, so at 10 hertz, we're going to compute we're going to use the cubic spline data to compute the required target position, velocity, and acceleration of the stepper motor. Then we're going to apply that to the stepper motor. Eventually, this needs to be much. Should we do this now? Yeah, so eventually this needs to be modulated by speed. We're going to say this now, so this needs to be modulated by speed. As follows. All right, so 1, if speed is below the cutoff, then do nothing. By cutoff, we mean the cutoff present here. Pattern controls, play controls, get some play controls. Draw play controls. Cutoff is, it's a bit of a mess here from BLE, so we're going to do a to do before I forget it. Where's Vaporeon? So speed limitation from BLE might have bugs. Just a note to self. Okay. Where is our do nothing if too low? Wow, it's all good. Yeah, speed. Da, 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 da. So if the speed has changed, yeah, we definitely have a stop if speed is too low thing somewhere. So we're just gonna say if speed is below the cutoff and we're gonna let it fucking figure it out, then do nothing. Hold position. 2. If speed is low, example, 1%. So if speed is high, this is the thing we can answer. If speed is high, i.e. 100%, then the time to complete the entire pattern is known. It should be 30 seconds. Is that crazy? Let me confirm this. Damn. Yeah, that's the condition I put in. That's real slow. So we have to do something slightly different. But if the speed is high, 100%, then take the minimum distance between any two consecutive points. Minimum distance in x between any consecutive points. Any two consecutive points. This is in the cubic spline. This is 0.1 seconds. Just brain dumping here. Right. So if the two minimum points are, you only have 2 points, just straight line, constant speed, no motion. And this would be good. Yes, it's going to like rescale so that at the highest speed, it assumes you're going the max speed of the machine between the minimum distance between 2 points. So like, yes, we're just achieving your maximum. This is good. This motion is, sorry, 0.3 seconds was the determined value. That is satisfactory. Use this value to back calculate all remaining speeds at 100% speed, and all remaining times at 100% speed. It's just a scaling factor. Really. Don't overthink it. Just a constant scaling factor. So then if speed is lower, I mean, we have a very simple approach now. This means the scaling factor can be used to determine how the pattern should play out, how the spline should be drawn for yeah, all remaining values. Very simple. All remaining values. Example, at 50%, those 2 points we used to determine the scaling factor, 50% speed, should take 0.6 seconds to traverse, etc. So on and so on. Okay, great. Temporarily ignore depth and stroke. We'll figure those out. But for now, we don't care. Okay, now to compute the required cubic spline, at time t without the scaling factor. Speed mentioned above. Our resources tell us that these are the critical equations. The critical equations to get from points and handles to continuous functions. Dope. So inside of the class that we're working on, the class was called spline pattern. Implement a function that returns the current value given the current time. We might consider doing a delta, but we won't worry about it. Track. Yeah, that's fine. Not worrying about it. Receive these here. Let's draw play controls. Da, da, da. Buffer. No. Buffer is a new thing added by our streaming friends. So draw play controls. Switch? Where's our switch statement at? No. Stroke patterns. Thank you. Keep file. So we want to draw these here. See those here. And set the stroker target position, velocity acceleration accordingly. All right, she's off. We're gonna let this bad boy turn. I'm gonna catch up the chat here to make sure people know the things I was talking about here, points 2 and 3. So how are we doing the scaling? Because I made some choices just now without talking to you about them, and I want to make sure that you are down. So the changes that we made, this is our current literal test pattern. This is the actual thing we're using. So the change we made is that like the time unit concept is just solidifying as follows. So if we have these 3 points right here, I am stating that at max speed, no matter what the points are, if you have 3 points or 4 points or 5 points, in fact, let's draw a more complex pattern just to make sure this is clear. We're going to make it just barely complex. In fact, we can go a little bit more complex because this one should also be 3 points. Let's not worry about it. Okay, so time check. I got 30 minutes, 28 minutes. I've just lost my canvas. Come on, Tim Cook. All right, recenter me. It's got to be a command for this. Center. Let's attempt this button called center. That did nothing. Thank you, sir. Thank you, Tim Cook. Okay, so let me fix that. Sorry, stream. There it is. So here are all the things that changed in those brief moments when I was rushing to put in some prompts to get something in front of you to take a look at. So the first thing that changed is we decided that the minimum distance between 2 points can be anything. We changed that notion. So we previously said the minimum distance between any 2 points is 1%. That is no longer the case. I've decided they can be anything. We are just going to enforce that in practice, the minimum distance will be computed, back calculated, so that it is 0.3 seconds apart. So changes. 1, the minimum distance between 2 points is no longer limited. I'm just going to assume the closest 2 points take 0.3 seconds to traverse at max speed. That is the assumption. This means you can send me anything. You could basically stack these points on top of each other. You could do this pattern, and I'm going to assume that this right here is 0.3 seconds at max speed. You could modify this pattern as follows. You could do this, and you could put it right here, right above. Looks faster than the graph above. It is not. It will be 0.3 seconds at max speed. Everything else will be scaled by your closest 2 points. That is change number 1. We have made this change so that your patterns are physically achievable. Good. That is possible. This is so. Are physically achievable. Okay, let me take a look at this bro. I'm gonna skim through his work. So we're going to try to read the pattern, evaluate the Hermite spline at time t, drive the stepper motor at 10 Hertz with the computed position, velocity, acceleration, scale playback using the settings.speed knob value. Yeah, you're reading through, you're understanding. Yes, position is 0 to 1. That is correct. Handle out. Our tangent offsets. That is correct. Hermite spline math. Good stuff. Looks approximately correct. First derivative for velocity. All right, down. Speed scaling. Okay. The biggest thing that this guy is going to struggle with is computing all of these values in steps on the stroke or on the stepper, I think. Excuse me. But catalog, floater file, evaluate velocity. I don't love that, but I'm okay with it. Binary search for the segment containing t. Huh. Okay. Well, we'll leave that. That is not required if we have an ordered list. It is interesting to do that as a binary search. 10 Hertz. Okay. 10 Hertz is all right. Stroke engine integration, pattern catalog. Yes, okay. Set of doing, set pattern. This is the trick here. So yes, we're running within the timing loop of is incorrect state. Yeah, okay. I mean, we'll have to see how it does its timing loop. I'm not too confident in its ability to do a nested timing loop. That seems insane. All right, man. Yeah, let's see what you got. 3, 2, 1, go. I don't think it's going to do the computation to steps correctly. I think the velocities are going to be wrong. We're going to hold out and wait. So let me just catch you up. I'm going to continue catching you up on the things that changed while I was just talking to the AI and not to you folks. Sorry. Sorry, not sorry. Okay, so physically achievable. Good stuff. I would love to see this whole text box. Thank you, Mr. Tim Cook. All right. Tim Apple, Tim Cook. Okay, so blah, 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 blah. Minimum distance between 2 points is no longer limited. Good. What else did I say to this AI in point 2? Coming back here. Yeah, don't care. So if it is below a cutoff, no problem. Yes, all right, so this is unnecessary. It's just additional information that says the same thing. So essentially, because I know this distance is going to be 0.3 seconds, I then can compute this distance. So in this case, it is also 0.3 seconds. It's an equilateral triangle. And then because I've computed my scaling factor here so that this is physically achievable, and this is going to be whatever it is, right? In this case, who knows? Maybe it's 3 seconds at max. This is at max speed. So we have good. We have good. That's all that matters. Okay. That is the biggest change. Let's see what's up. AI is clicking along. There was one other change that I made when chatting with the AI that I wanted to make sure was clear to folks. Yeah. Okay, at 10 hertz loop, no problem. Interesting the choice that you're making, Mr. Robot, but I will let you go. Let's take a look at this. So we pushed in this equation, which is chill down. Yeah. I didn't find the code for the cutoff. I do know we have a cutoff. I am going to guess at the moment that it lives inside of Stroke Engine. From memory, I am 100% certain there's a low speed cutoff because the actual stepper, at least on IHSV, would stall if you were too low, if you set too low of a speed. So it just made more sense just to say, like, if you're below 1%, just stop. I don't know if the gold motor has that issue, but we do still want to make sure the IHSV is considered. It is in production on a lot of machines, so might as well. Okay, hanging. Break out the inner loop when pattern changes. Give stroker. All right, well, AI did something. Let's go find out. Let's see. Let's see if we're in motion. Okay. LFG. So we're gonna do Command P, terminals run. Where's my terminals, baby? Here we go. Wrong device. Too many things plugged in. Okay, awesome it is. And PIO run. Let's go. Let's see what's up. So the patterns, again, that we provided inside of data, in the data patterns directory, they are just trapezoids. They should be very simple. What we're going to be watching for as this goes, is this dead? No, 23%. So we're watching for jitter because we are running a simple trapezoidal pattern, very simple. And see, there you go. Phone's taped to a flexible thing, so I gotta remember not to move too much. Okay, so we have a simple line. Yeah, we're gonna find out. Jitter was the highest risk. The other risk, which I think we're gonna avoid by sending commands at 10 hertz, is flooding the motor command queue. We'll see. She's compiling. Taking her time. In the meantime, while it's building, let's off screen here, I'm just gonna go into GitHub, do a branch. So we have a dev thing going. Add commit, add message temp. we're going to say add message early draft of pattern control. Okay, push. Love it. You can't see anything I'm doing at the moment. I'm just cracking open GitHub on my non-guest browser. If you can see it, you should holler at me and let me know, because that is not desired. And when I make a PR, it should automatically upload a test build or a dev build into the docs website. So that's docs.researchanddesire.com. From there, you'll be able to find quite a bit of good stuff. So you'll be able to specifically find the branch that I'm using, which is called AJ/awesome patterns. And on AJ Awesome Patterns, you'll be able to flash your device from the browser and ideally experiment with what I'm working on. This is a draft ready for review. Definitely not ready for review, but let's go forward anyway. Go forth and conquer. Okay, she's moving. Let's get you on something. Let's get you on logs. I think that's the most fun. Let's go here. Let's close this one. Here's our logs. See ya. Bye. You can hang out here and look at those. I'm going to open OBS, make sure we're working as expected. You can see me. Hello, hello. Let's see what happens. So if I go down, you can't see my remote. That's okay. I'm going to go into Stroke Engine. Going to just confirm. Okay, we have basic Stroke Engine stuff working. I'm going to switch patterns. Okay, we're going to go down to the pattern called test pattern, which you should be able to see here. Loaded from file, spline pattern, loaded, test pattern, 3 points, duration, 1. Good, no units. Min dx. Okay, so it is computing our scaling factor. Bad. So what you can see there is it immediately hit the hard stop. So this is where I believe it's now failing to compute position on stepper from these patterns. So let's have it not send commands, and in fact, just have it send just log. Yeah, okay. You're fucking up, bro. Big bro. So you didn't see it, but right now it's deadlocked here against the back hard stop. It didn't slam because I did a fairly low speed. Let's try. Can you please just log the planned target? You know what? What are the odds it's just backwards? Okay, I'm just gonna try something. Okay, we're just gonna unplug the motor. Super unsafe right now. I've just lost homing. I have no idea where my position is, but I just want to see. Just slow speed. If it just goes to the front hard stop, that'll be so funny. Yeah, okay. Well, let's just put it here. Not a big fan right now of whatever it's doing. Because it also doesn't look like our pattern. Yeah, I'm sorry. Okay. So one, for testing, only use 50% of the stroke range. Thanks. Two, I think yeah, your position targets seem to be negative. Yeah, what's up here? Huh. Sorry, not reading chat, catching up with you, Steven. Is the pattern web UI generating the JSON we would need to test patterns? No. No, so going back to freeform, we've jumped around a little bit. So we wanted to prove the minimum for the MVP the minimums that we have proved are, I'm not sure why this is failing, that we can draw patterns and save them successfully. We have, however, not finished the portion here, which would, through Bluetooth, send a pattern to device. However, because we are just in general testing this flow now, because we're testing the second biggest conclusion, which is that second biggest hypothesis, which is that if we have, oopsie doopsie, what's going on? Okay. If we have a pattern stored in memory, presumably received by the dashboard, that we can create a motion planner which does successfully draw that pattern. To answer your question, simply no. There will not be web UI for you to test. However, if you want to test, I recommend just going here, manually modifying data.json right here. Simply because in the next 10 minutes before I have to call this and leave, I will not be able to release the code that I want to in a way that is safe. The intent, though, is that I will release a semi-testable version of the dashboard code before Monday, so that over the weekend, folks can give it a shot. Okay, done. Bro did the thing we asked. I think I'm right about the issue. So we're gonna jump in here, run the same. Almost there. So close. Locked in. I think this last hour is going to be like me just staring at my computer a lot. I keep forgetting to look up. You're all right over there. But I do know you're there. I remember. Yeah, for testing, there's a branch I've pushed into remote called AJ/awesome-patterns. It's missing some of the latest, so you're going to have a recent bug. But before end of stream, I'll make sure everyone has access to it. The hope is also that the web flasher on on the doc site gives you access to this. I will check that now while I wait for this to home. So on the doc site, if my release has finished, then you should see something here. However, I do not see it, which implies something broke. Quick check to see if that's the case. Yeah, confirmed. Yeah, confirmed my release broke. So yes, it is called AJ Awesome dash patterns. AJ/awesome dash patterns. I'll send it to chat and put it on screen. Okay, let's go check. So I'm going to go over to, can't see it, stroke engine. Just going to confirm things are not broken. Not broken. Good stuff. Going to switch patterns. Going into test one. Let's hide this. You have full screen. Full screen. Here are our logs. Okay. Test pattern. Let's go. And okay, so I think I was right about it being negative, which is good. And we are happy to see that it's only using 50% of the range for safety. We are seeing some sign of jittering. You can see it there, a couple of stutters. I also note that when I change the speed, it's a little bit discontinuous. You see right there, as the speed changes, it's a bit discontinuous. And I know for a fact, this is not top speed, Mr. Awesome. So somewhere our computation went wrong. So let's make some notes. I'll push this code so anyone who's live right now can take an early look. I'm going to list the issues. Okay. So here are the outstanding issues as I see them. Yeah. Problems. So the branch, first off, It's awesome. Sorry, it's AJ/awesome dash patterns. Just note, not safe for play. No web UI yet, but you can edit data/patterns slash id.json. Okay. Problems. 1. Yeah, our max speed calculation must be wrong. This is supposed to be operating at maximum speed between these 2 points. That 0.3 second, the 0.3 second thing that we stated. I'm just gonna think back here. Maybe we have to inverse this calculation and just like, yeah, okay, I'm gonna make this note. So yes, the speed calc seems wrong. Right now we're scaling by my calculation for the time it should take between 2 points. Right now we're scaling by my calculation for the time between 2 points at max speed. But we have max speed and we have the rail length and the rail length and the not importantly not the rail length, the operating play length, the operating and rail length. So the things that need to change are we should just use the saved max speed to compute the time between these points. Time between the 2 nearest points. That's fine, we could do that. And we should use the homed play range. Instead of the rail length for this calculation. Right, because it was assuming a 300 millimeter rail, but even on this rail, we probably only play with like 22 centimeters. Okay, the other thing is speed changes are not continuous. So I'll show you again what I mean. When I decrease the speed here, see that? It just like, it jumps to a different point in the pattern completely. So what I would want, I'm gonna go up to very low speed. And it seems to do okay, but it's just like, the jitter appears, like this is supposed to be a in and out penetration cycle. So what I think is occurring is literally a discontinuous pattern. I think it doesn't know how to continuously compress like between speed A and speed B, we're gonna have 2 different versions of this spline, and they must be continuous between each other. And I think that's not the case. I think that if I jump really quick, I'm immediately setting myself up with another version of this pattern at a different point in time, and I'm not like making sure, I'm not guaranteeing continuity between the two. So speed changes are not continuous. So when I have changed speed, I essentially have a different function, which for all intents and purposes has been running since the start of the play, which as far as we care, has been running since start of play. And it just snaps to whatever point in time that function would be at. It's jumping to whatever point in time. Not a fan. Needs to be continuous. Must be continuous. What else am I a little disappointed by here? I don't know. I think it's probably, we have the April tracker, the April tag on top. So I'm going to be able to do a good analysis next time to see if it's actually reasonably representing the profile we sent it. And I can estimate the error. So I'm just going to put a note for myself here. So April tag, identify the amount of error in representing this pattern. Okay. And then, of course, we want to bring in stroke and depth into the consideration. Huh. Okay, these are the outstanding pieces of work on motion controlling at all. There's a lot more work in general to get this MVP feature out, but I'm out of time. I got coffee with a friend, so I'm gonna shake it off and just yeah, jump into chat here, see how folks are doing, and we'll go from there. So one moment, finding you. Hey Lucy, it occurred to me that it'd be super cool to select a region of spline where the end effector will rumble as it traverses it. It'd be super fun to have the awesome vibrate in place for the most minimal of stroking too. Yeah, absolutely. So before I read yours there, Stephen, one thing that we talked about in a previous session was having event markers. So we were talking about, well, sensation is completely ignored in this context. So how do we re-include it? And the idea is that in the drawing tool, I'll show you here, the conversation we had is you could place an event marker. Where is it? Did I do it? Yeah, I put it as a unicorn thing. It's probably the first time I used the unicorn, so the language is a bit off. But you could add a point where something would occur, where a filter appears on the pattern. The filter would be a vibration mode, or it would be a pause. And this would then be sensation modulated. So if your sensation was 0 and you had a vibration pattern or vibration filter, then it would be 0% of that vibration. You get 0% of that filter applying. If you had a pause filter, then at 0%, you get 0 pause. At 100%, you get whatever's max configured for that filter. Like if it's a 10-second pause, you get 100% of that. If you have a again, 100% vibration. We don't have a meaning for that yet, but that is super possible, and we love it. Okay. Yeah, Stephen, you had said it's probably regenerating the loop and starting it from starting it. Yeah, something to that effect. I think what's literally happening is that it's not restarting the loop. I think what's literally happening is that it is guessing here because I did not read its equation code, which is a risk. My guess is that, let me see if I can make this make sense to both of us. If you imagine I was doing this with a sine wave, right? And you had a frequency modulator in the sine wave, the math would be something to the effect of like t over x or t times frequency, something like this. And if it's t times frequency or t divided by frequency, whatever the math ends up being, then if you change the frequency dynamically, but you're already evaluating at a point, say time is 1 second or time equals 0.5 seconds. But you change the frequency, then you are pseudo randomly jumping. Hey, thanks, Lucy. Thanks for joining. See you around. But you're pseudo randomly jumping to wherever the new function with the new frequency, totally new function, would be at time equals 0.5 or time equals 1. So it's just two discontinuous functions that we're trying to staple together. That's the issue as far as I see it. All right. Hey, folks. Well, we got 7 folks here. I appreciate every single one of you for coming in. The state is that the OSSM is moving to a pattern with a couple of issues, and you can test it out. I'm going to make a quick announcement in the chat, and I will schedule the next one. Hey, Fred, thank you so much. I absolutely love doing these for real, and I seriously appreciate that you were here. Honestly, love it. Like I said, I'd be going insane talking to this damn fish if it wasn't for you. So appreciate you. Thank you, Stephen. All right. Okay, I love you both. I'll send the YouTube video shortly once this is ready. It'll take a little bit of time for Twitch to process this. Ah, god dang. I think I have to hang out for 5 more minutes to get an achievement on Twitch, actually. So I'm just gonna go grab a water and let this run for literally 5 more minutes to get the 4-hour achievement on Twitch. Because I'm a sucker. So I'll put up a note here. I'll see you all again soon. I have a next scheduled one on Saturday, but I intend to do one sooner than Saturday. That will be more potentially at my convenience. However, I do recognize the 6 a.m. ones are extremely good for our North American and European folks. The 6 a.m. my time zone. Um, I'll keep you in the loop. Best place to watch is on the Research and Desire Discord, our Twitter, Instagram, Reddit, or the Kinky Makers Discord. Any of these will be a good place for you to find this information. 4 a.m. here. Dang. Dang, where are you? Where is it 4 a.m.? Dang. Oh, yeah. Okay, sure. All right. Well, yeah, don't reveal. Oh, UK. Oh, that's terrible. I really, y'all, I tried to optimize and I failed completely. I'm gonna attempt to find a slightly better time for our European friends. And damn, that's so funny. Okay, we'll work on this. We'll workshop this. Uh, I'll do one of those calculators that figures out like a perfect overlap between Bangkok, Europe, and North America. Okay, I'm gonna go grab my water and let this run for 3 more minutes. I'll just leave a note for anyone that I'm doing that. But yeah, thank you all. See you again soon. Bye bye bye.
Oh, oh, my feet are asleep. Oh. Oh.
Bye.